discovery in Antarctica, researchers find new life under an ice shelf, and the discovery was an accident.
Wow.
The last remaining territory on the planet that could have such a designation is Antarctica.
Have you ever pondered the secrets that the icy expanse of Antarctica might be hiding beneath its surface? This vast, frozen wilderness is a realm of endless white, a place where the sun shines at midnight in the summer and hides in the winter. It's a place of extreme temperatures where life seems to be hanging by a thread. Yet, it's also a land of mystery and intrigue, largely untouched by human hands. Antarctica, our planet's southernmost continent, has long been a source of fascination. Its harsh, cold environment has kept us at bay, preserving its secrets under miles of ice. But in recent years, that ice has started to give up its secrets. As our technology improves and our thirst for knowledge grows, we're starting to delve into the mysteries that Antarctica has held onto for millennia. Various countries and scientific communities have turned their attention to this icy expanse, each hoping to unlock its secrets.
Scientists are also increasingly concerned about what's happening to the sea ice around Antarctica.
Russia, in particular, has been at the forefront of these explorations. Their scientific expeditions, equipped with modern tools and cutting-edge technology, have ventured into the frozen heart of Antarctica, braving the cold and the isolation in the name of discovery. These explorations have led to discoveries that have captivated the world, shedding light on the unseen depths of Antarctica. Beneath the ice in the coldest place on Earth, life thrives in unexpected ways. Hidden mountains reshape our understanding of Earth's geology, and ancient meteorites reveal new insights into our universe. Every discovery in this icy wilderness opens up new questions, pushing the boundaries of what we thought we knew about our planet and life itself. So, what did Russia recently discover in Antarctica that has left everyone terrified? As we delve deeper into the secrets of this icy wilderness, we find that Antarctica is not just a desolate, frozen landscape. It's a dynamic, living environment, holding clues to our past and keys to our future. But some of these keys unlock doors that perhaps should remain closed. Join us as we journey into the unseen depths of Antarctica and uncover the terrifying discovery that has shocked the world: life beneath the ice. Imagine discovering alien-like life forms in the most unexpected of places. This is precisely what happened when researchers stumbled upon new life forms lurking beneath the Antarctic ice shelves. These aren't your garden-variety organisms. These are extremophiles, organisms that thrive in conditions that would be inhospitable, even lethal, to most other life forms. It's a world where the sun never shines, and the pressure can crush a submarine. The cold is beyond biting, it's numbing. Yet in this harsh and forbidding environment, life finds a way. These organisms challenge our understanding of life's resilience and adaptability. They're a testament to life's tenacity, its refusal to be confined by what we perceive as limitations. The discovery of these life forms is more than just a fascinating insight into the biodiversity of our planet. It's a paradigm shift. It compels us to rethink our definitions of habitable environments, pushing the boundaries of where life can exist. Could this mean that there's life on other planets, hidden beneath the icy crust of a distant moon perhaps? Could these extremophiles be the key to unlocking the secrets of extraterrestrial life? The implications are as profound as they are exciting. And these organisms don't just exist in isolation. They're part of an intricate, interconnected ecosystem that's been evolving in isolation for millions of years. It's a glimpse into a world that time forgot, a living time capsule that holds clues to our planet's past and possibly its future. These discoveries have only scratched the surface of what lies beneath the Antarctic ice. It's a realm that's as mysterious as the deepest oceans and as alien as the farthest reaches of space. And it's right here on our doorstep, waiting to be explored. But that's just the beginning of the mysteries Antarctica is hiding. The microbial mysteries of Lake Vostok. Now let's delve deeper into the icy depths of Lake Vostok. In this remote, under-ice lake, located miles beneath the Antarctic ice sheet, scientists have discovered a world teeming with life. These are not your everyday garden-variety microbes. No, these are extremophiles, organisms that thrive in conditions so harsh, so extreme, that they defy our traditional understanding of where life can exist. The extremophiles of Lake Vostok exist in a world devoid of sunlight, under crushing pressures and temperatures that would freeze most life forms in their tracks. Yet they do more than just survive. they thrive. These microbial marvels have adapted to a life in the deep freeze, developing unique biochemical strategies to cope with their icy home's extreme conditions. But the significance of these extremophiles extends far beyond the icy confines of Lake Vostok. Their existence raises profound questions about the very nature of life itself. If life can survive and even flourish under the ice of Antarctica, where else might we find it? Could similar extremophiles exist beneath the ice of Mars or the moons of Jupiter? These tiny organisms could be the key to unlocking one of the greatest mysteries of our time. Are we alone in the universe? The discovery of life in Lake Vostok broadens our understanding of what is possible and gives us hope that we may one day find life in the most unexpected corners of our solar system. So in this icy, alien world, scientists have discovered not just a new form of life, but a new way of thinking about life itself. The extremophiles of Lake Vostok challenge our preconceptions, expand our horizons, and inspire us to keep pushing the boundaries of the known world. And while life thrives beneath the ice, there are mountains hidden beneath it as well. Hidden peaks and subglacial landscapes. Beneath the ice of Antarctica, a mountain range looms. A startling revelation indeed, but one that's perfectly true. The gambits of mountains, a range buried under kilometers of ice, are a testament to the unending surprises our planet holds. This subglacial mountain range, discovered in the late 50s, has been a source of intrigue and study for decades. These hidden peaks, invisible to the naked eye, challenge our understanding of Earth's geology. Imagine mountains as big as the Alps, nestled deep under the frosty Antarctic surface, invisible to the world above. The gambits of mountains play a crucial role in shaping the ice that covers them. They dictate the flow of the ice, carving paths and directing its movement like an unseen conductor. These icy rivers, dictated by the mountain's whims, carry with them a wealth of information about our planet's past. The ice cores harvested from these regions serve as a time capsule, preserving the record of ancient climates. They offer us a glimpse into the Earth's atmospheric conditions thousands of years ago and how they have shifted over millennia. But the implications of this hidden mountain range extend beyond historical records. They hold the potential to influence our future. The Gambetsev Mountain's effect on ice flow is a vital factor in predicting changes in ice sheets and consequently global sea levels. The rise and fall of these levels, influenced by the melting and freezing of ice, is a crucial piece of the climate change puzzle. Understanding the role these hidden peaks play in this grand scheme could be the key to unlocking accurate predictions about our planet's future. From hidden mountains to celestial mysteries, Antarctica continues to amaze. These peaks beneath the ice remind us that even in the most inhospitable and desolate places, there are secrets to be discovered, stories to be told, and lessons to be learned. Meteorite mysteries and the Tunguska event. The cold of Antarctica hides not just earthly but cosmic secrets. This icy landscape is a veritable treasure trove of meteorites, remnants of the early solar system that have fallen to our planet's surface. In some ways, these space rocks represent a time capsule, offering us a glimpse into the birth and evolution of our solar system. One of the most intriguing connections between these Antarctic meteorites and cosmic events is the mysterious Tunguska event. In the early morning of June 30th, 1908, over the remote Tunguska River in Siberia, an explosion occurred. The blast, estimated to be 1,000 times more powerful than the atomic bomb dropped on Hiroshima, flattened over 80 million trees but left no impact crater. The cause of this explosion has been a source of debate among scientists for over a century. Some scientists believe that the Tunguska event was caused by an asteroid or a comet that exploded in the Earth's atmosphere. This theory is supported by the fact that meteorites, similar to those found in Antarctica, have been discovered in the Tunguska region. These meteorites, composed of rock and metal, provide insights into the early solar system and potential threats from near-Earth objects. Studying these Antarctic meteorites and their potential connection to the Tunguska event helps us understand the dangers posed by near-Earth objects. It's a fascinating reminder of how interconnected our planet is with the wider universe, and how events millions of miles away in space can have profound effects here on Earth. But not all of Antarctica's mysteries are hidden beneath the ice. The enigma of Blood Falls, a red waterfall in the icy white landscape, an anomaly that has puzzled scientists for decades. Welcome to one of the most mysterious spots in Antarctica, Blood Falls. A stark contrast to its freezing surroundings, Blood Falls is a spectacle of nature. pouring forth a red-colored stream from the Taylor Glacier. What gives this waterfall its eerie crimson hue? The secret lies deep within an ancient subglacial lake. Over 2 million years old, this lake is a time capsule from a prehistoric era, trapped beneath the thick Antarctic ice. It is rich in iron, which, when exposed to air, rusts, creating the stunning, blood-like color we see. But the secrets of blood falls extend beyond its mesmerizing appearance. This phenomenon is a testament to life's extraordinary resilience and adaptability. The water from the subglacial lake is 3 times saltier than seawater, and it is devoid of oxygen and sunlight. Yet, against all odds, microbes have found a way to survive in this extreme environment. These microbes are anaerobic, meaning they can live without oxygen. They have adapted to this harsh environment by developing a unique metabolism that relies on sulfate and ferric ions, which are abundant in the iron-rich water. This discovery of life in such an extreme and isolated environment expands our understanding of the limits of life on Earth. Moreover, Blood Falls offers invaluable insights into our planet's past climate. The preserved conditions within the subglacial lake provide a window into the Earth's climate over 1 million years ago, a time when the lake was first sealed off from the atmosphere. So, while it may seem like an alien landscape, the enigma of Blood Falls is very much a part of our world, a testament to life's tenacity and a glimpse into our planet's ancient past. These discoveries are just the tip of the iceberg. The mysteries of Antarctica continue to unfold. The terrifying revelation.
So a new discovery in Antarctica.
So, what is it that Russia discovered that has left everyone terrified? In the unforgiving and frigid landscape of Antarctica, researchers have unearthed secrets that have changed our understanding of life and our planet. But these revelations do not come without their own set of fears and concerns. The discovery of extremophiles, microorganisms that thrive in the harshest of conditions, are a testament to life's resilience and adaptability. Yet their existence raises unloving questions. If such life forms can survive in the inhospitable environment of Lake Vostok, what other, potentially harmful, organisms might be lurking in the uncharted territories of our planet or even beyond? Then there are the hidden gamberts of mountains, a geological marvel that has reshaped our understanding of Earth's structure. However, these mountains, buried under layers of ice, have a significant influence on ice flow. As our planet warms and this ice melts, we could see a rise in global sea levels, a consequence that threatens coastal communities worldwide. This terrifying possibility underscores the urgency of addressing climate change and preserving our polar ice caps. The connection between meteorites found in Antarctica and the Tunguska event in Siberia reminds us of the inherent risks associated with near-Earth objects. These meteorites are windows into the early solar system, but they also serve as a stark reminder of potential threats from outer space. Lastly, the enigma of Blood Falls, a phenomenon caused by iron oxide from an ancient subglacial lake, expands our understanding of life's adaptability. It also hints at Earth's past climate conditions, a chilling reminder of the planet's ability to undergo radical changes. The icy expanse of Antarctica still holds many secrets, each more intriguing and terrifying than the last. To zoom up, A World to Discover has taken you on an unforgettable journey through the frozen heart of Antarctica. From the depths beneath the ice to the wonders of Blood Falls, we've explored life's resilience and Earth's hidden geology. Our adventures have revealed the critical role this icy continent plays in understanding climate change, life's adaptability, and our interconnectedness with the cosmos. But wait, theories as MMOA. As we continue to delve into these icy mysteries, each discovery not only captivates but also educates, pushing the boundaries of our knowledge. Keep exploring with us and stay amazed by the never-ending wonders of our incredible planet. Remember, every video from A World to Discover brings us closer to the next great discovery of our planet.
5, 4, 3, 2, 1, 0. All engine running.
I am Buzz Aldrin.
One small step for man, one giant leap for mankind.
And I was the lunar module pilot on Apollo 11.
Stage 5 clear. Roger.
We have a liftoff, 32 minutes past the hour. Liftoff on Apollo 11.
Buzz Aldrin, one of the few men to have walked on the moon, possesses unique insights about it thanks to his experience as a lunar astronaut. Later in life, he shared intriguing observations, hinting at mysterious entities or phenomena close enough to be observed on the moon. Does Aldrin's observations challenge conventional knowledge about the moon?
I thought it was a good idea in front of the TV to bounce around and to demonstrate how easy a guy could move around, or a gal could move around on the moon.
Is the moon not what we think it is? Let's learn more about this person. Buzz Aldrin, an astronaut renowned for his academic prowess, including a PhD from MIT, played an instrumental role in the historic Apollo 11 mission as the lunar module pilot. As the pilot of the lunar module, Aldrin had a massive job. He had to land on the moon and then make sure they could get back to Earth safely. This guy wasn't just very intelligent. He was also a top fighter pilot in the Korean War. His mix of brainpower and flying skills was key to the mission's success. But there's more. We're also looking at how Aldrin kept his cool under pressure. Imagine this: you're descending to the moon and you're hit with computer alarms, unknown boulders on the surface, and your fuel's running low. Sounds scary, right? Well, Aldrin, alongside Neil Armstrong, handled it like a pro. His ability to stay calm and make quick, smart decisions was crucial, especially during those tense moments. Thanks to him, the Eagle landed safely on the moon. Stay tuned as we explore the amazing journey of Buzz Aldrin on Apollo 11. The historic moon landing. Guess what? Buzz Aldrin was the second guy to walk on the moon, right after Neil Armstrong. When he stepped onto the moon, he didn't just make history, he became a part of it. But walking on the moon was just one part of his mission. Aldrin was super busy up there, setting up all sorts of science experiments. These weren't just any experiments. They were designed to help us learn everything about the moon, like what it's made of and what its surface is like. Thanks to him, we know a lot more about the moon now. Aldrin also did something really important. He planted the American flag there. This wasn't just about being patriotic. It was a big moment showing what humans can achieve when we aim for the stars. And there's the special thing he did that not many people know about. While he was on the moon, Aldrin took some time for a personal spiritual moment. He actually took communion. It's a reminder that behind all the science and exploration, there's a human touch. Let's talk about how Aldrin described the moon. He called it magnificent desolation. What a way to describe it. It's like he was saying the moon is incredibly beautiful, but also really empty and quiet. It must have been such an unreal experience to stand there in this huge, silent place, so far from Earth. Space sickness experience. Let's dive into something that is about Buzz Aldrin that is not talked about much. His experience with space sickness during the Apollo 11 mission. You know, being an astronaut is not just about the cool stuff like floating in zero gravity or walking on the moon. There are some tough challenges too, and space sickness is definitely one of them. You can compare it with seasickness if you have ever had it before. Now, when Aldrin was up there in space, he actually got really sick. But here's the thing. Back then, nobody really talked about it. It wasn't until later, in his autobiography and some interviews, that Aldrin opened up about this experience. This was a big deal because it showed a side of astronauts we don't often see, their human, vulnerable side. Space sickness, or what they call motion sickness in space, can be pretty rough. Imagine feeling dizzy, nauseous, and just all around terrible while you're trying to do your job millions of miles away from Earth. It's not fun. Aldrin dealing with this while on such an important mission just shows how tough and resilient astronauts have to be. But why is this important? Well, it reminds us that astronauts are people too. They face challenges and have to overcome them just like the rest of us. Aldrin sharing his story of space sickness helps us understand and appreciate the real, human side of space exploration. It's not always smooth sailing or smooth flying in this case. Theories on extraterrestrial life and moon's far side. Now let's talk about something that's really out of this world. Buzz Aldrin has dropped some hints that have got everyone talking. He suggested that there might be hidden structures or even bases on the far side of the moon. This could mean something huge, like ancient civilizations or extraterrestrial activity. This idea isn't just some sci-fi fantasy. It's coming from a man who's actually walked on the moon. So when Aldrin talks about these possibilities, people listen. His comments have sparked a ton of interest and loads of speculation, not just among space enthusiasts, but even in the scientific community. Now think about it. The far side of the moon is this mysterious place that we've never seen from Earth. So when someone like Aldrin hints at something hidden over there, it's no wonder everyone's imagination goes into hyperdrive. Could there be structures we've never seen before? Signs of ancient moon visitors? Maybe even evidence of aliens? These ideas have sent people rushing to look at lunar images and data, searching for any clues that might support Aldrin's suggestions. But here's the thing. While some people claim they found evidence of weird structures or unnatural formations on the moon, a lot of it could be our brains playing tricks on us, seeing patterns that aren't really there. That said, the fact that a seasoned astronaut like Aldrin even entertains these ideas adds a serious dose of intrigue to the whole discussion. Observation of a mysterious object in space. During the historic Apollo 11 mission, Aldrin reported something extraordinary. He observed an object in space that he couldn't identify. This wasn't just a piece of their spacecraft or some random space junk. It was something different, something that even a seasoned astronaut like Aldrin couldn't recognize. Now, imagine this. You're thousands of miles away from Earth in the vast emptiness of space, and you see something mysterious floating out there. That's exactly what happened to Aldrin. This wasn't a quick glimpse either. He saw an object that seemed to move in a controlled way, not just tumbling through space like debris. This sighting was unusual enough to catch the attention of the entire crew. This sighting sparked a lot of conversations and theories, especially about the possibility of extraterrestrial life. It's one of those incidents that make you wonder what's really out there. Was it an optical illusion, a reflection, or something more? Some space enthusiasts even dared to ask if it could be evidence of intelligent life, taking an interest in humanity's first journey to the moon. Aldrin has been open about this experience, discussing it in interviews and being transparent about what he saw and felt. He didn't jump to any wild conclusions, but he also didn't dismiss what he saw as nothing. This account from Apollo 11 adds a layer of mystery and excitement to the mission's story. Belief in extraterrestrial life. Aldrin has some other fascinating thoughts about life beyond Earth. Think about it. The universe is incredibly huge, with billions of galaxies, each filled with billions of stars. Around those stars orbit countless planets. Aldrin thinks that in all that immense space, it's almost more unlikely that Earth is the only place with life. He's not just dreaming big. He's basing his ideas on the probabilities given the size of the cosmos. But Aldrin doesn't stop at just believing there's life out there. He's a big advocate for continuing to explore space, to push further into the unknown. Why? Because he thinks that by exploring, we might actually find other life forms. Imagine the breakthroughs and the leaps in understanding we could achieve if we encountered life beyond Earth. Aldrin's perspective is really a call to action for humanity. He's urging us to keep exploring space, not just to satisfy our curiosity, but also to connect with potential life out there. This isn't just about launching rockets and satellites. It's about a deeper understanding of our place in the universe. Life on the moon, possibilities and challenges. Now, when we think of the moon, we usually picture this barren, desolate landscape with extreme conditions. It's a place with no atmosphere, extreme temperature swings, and bombarded by cosmic rays and solar winds. Not exactly the kind of spot you'd think life would call home, right? But there's more to this story. It's this wild idea that life can actually hitch a ride across the cosmos, potentially even reaching the moon. This could happen through asteroids, comets, or even interstellar dust. Imagine tiny life forms or organic materials getting a lift from Earth or other planets and ending up on the moon. But that's not the only way life could make it to the moon. Human activity could also play a part. We've been sending spacecraft and landers to the moon since the 1950s. Now, what if some of these missions accidentally carried microscopic stowaways? It's entirely possible. In 2019, an Israeli spacecraft called Bereshit crashed on the moon. But it wasn't alone. It had a payload that included thousands of tardigrades. If you don't know what tardigrades are, they're these tiny, tough animals that can survive extreme conditions. We're talking about surviving in space. So there's a chance these little guys could be living it up on the moon right now. Now, we're not saying there's a thriving ecosystem up there. If there's any life on the moon, it's probably super simple, like bacteria or fungi. And it would have to be in very isolated spots, like inside rocks or in ice at the poles. While it's unlikely that the moon has its own native life forms, the idea that life could hitch a ride that isn't so far-fetched. It's these kinds of possibilities that make space exploration so exciting. We're constantly learning and re-evaluating our understanding of life in the cosmos. What do you think? Do you believe in Buzz Aldrin's observations? Could it possibly be any life beyond our planet, or even on our neighbor the moon? Let us know your thoughts in the comments below. We hope you found these facts intriguing. If you heard them before or have any thoughts to share, please let us know in the comments below. Don't forget to give us a thumbs up and subscribe to A World to Discover to join us on our journey of discovery.
Astronomers were caught off guard in 2017 when an unusual object was observed speeding through our solar system. Known by its Hawaiian name, Oumuamua, which translates to a messenger from afar arriving first, this object was unlike anything that had ever been seen by scientists. Oumuamua was the first known interstellar visitor because of its lengthy, cigar-like shape and unexpected trajectory, which suggested origins outside of our solar neighborhood. A new angle surfaced just as the scientific discussion was starting to level off. A stunning discovery has been made by NASA in recent updates. Oumuamua is returning to Earth. This unplanned return trip offers us a unique opportunity to examine this enigmatic object up close, which has us excited and worried about what Oumuamua might uncover on its second approach. Come explore the specifics of Oumuamua's original discovery, its fascinating features, and the potential implications of its return for our comprehension of the universe. At the Pan-STARRS 1 Observatory in Hawaii on October 19, 2017, astronomers noticed an odd object. Astronomer Dr. Robert Warwick, who studies cosmic events, was going over data when he noticed something unusual. The object that would eventually be known as Oumuamua bore little resemblance to the common celestial bodies that orbit our solar, such as comets or asteroids. Its discovery, which made it the first known interstellar object to reach our solar system, was exciting and unexpected. Oumuamua's form distinguished it from other known space objects right away. It was perhaps 800 meters long, but barely 80 meters broad. It was extremely thin, more like a cosmic cigar or needle. Scientists were interested by its novel dimension as well as its tremendous speed and trajectory. Oumuamua was first categorized as an asteroid because of its stony appearance and lack of the usual comet coma and tail. But as Oumuamua started to leave our solar system, it showed characteristics more reminiscent of comets than asteroids. It began to speed up, which is characteristic of comets since they expel gas and dust when heated by the sun. What's even more puzzling is that Oumuamua did not exhibit any outward manifestation of this common cometary outgassing. There was no tail following its trajectory, no gas or dust emissions observed, and no hazy halo. Scientists are baffled by this strange combination of traits, asteroid-like in appearance, but comet-like in behavior without the expected visual cues, which has sparked a flurry of scientific theories and research aimed at figuring out the true nature of this interstellar visitor. Oumuamua differs greatly from the common space objects that go through our solar system, such comets and asteroids. Its shape is unique to begin with. It is remarkably long and narrow, like a cosmic cigar, and unlike any comet or asteroid that has ever been spotted. Most comets have a tail and a murky coma when they approach the sun, while most asteroids are roughly spherical or irregular in appearance. But Oumuamua showed none of these characteristics. Its long, needle-like form and lack of a tail or coma defy our preconceived notions about what other solar system entities ought to look like. Astronomers were also puzzled by Oumuamua's actions throughout its transit through our solar system. Its entry at a hyperbolic trajectory, as opposed to a typical elliptical orbit, suggests it wasn't gravitationally tied to the sun. Rather, it was merely passing through, most likely from another star system. The most remarkable thing about Oumuamua's departure from our solar system is that it showed non-gravitational acceleration, a speed increase that isn't usually seen in inert space rocks. Outgassing, the process by which ice near the sun converts to gas and produces a push akin to a jet, is typically the cause of comets' characteristic behavior. However, Oumuamua did not exhibit any outgassing symptoms, which left astronomers perplexed by its acceleration. Here's where Harvard professor Avi Loeb presents a thought-provoking viewpoint. According to Loeb, Oumuamua's unusual shape and velocity might not only represent anomalies, but also a sign that it is not a naturally occurring object at all. He speculates that it might be a light sail, or at least a piece of highly developed technology from another civilization. Similar to how a sailboat gathers wind, a light sail is made to capture sunlight particles in order to move through space. According to this proposal, Oumuamua's remarkable acceleration in the absence of cometary activity may be caused by pressure from solar radiation. Although this theory deviates from science fiction and has drawn criticism, it forces scientists to explore wider avenues in their continuing effort to unravel the mysteries of Oumuamua and potential future interstellar objects. The scientific community is thrilled by the finding of Oumuamua. There is nothing like this strange, cigar-shaped extraterrestrial visitor that astronomers have ever seen. Its genesis is not only outside the gravitational pull of our sun, but its features also contradict the accepted wisdom regarding the appearance of celestial bodies in our own solar system. Oumuamua's interstellar nature has significant consequences. It provides astronomers with the first concrete proof that things can move between star systems, opening up a new area of study. This discovery casts doubt on earlier astronomical ideas and raises numerous queries regarding the ejection of such objects from their initial systems, their motion across the vastness of space, and potential interactions encountered during their travels. Furthermore, Oumuamua's arrival offers a once-in-a-lifetime chance to test and improve our tracking and detection systems for fast-moving objects that come from beyond our solar system. Its existence promotes the creation of new models that provide light on the mechanics of interstellar travel, particularly the movement of objects through the interstellar medium. The fact that Oumuamua can teach us about other star systems without requiring us to send probes to far-off stars is another reason why the scientific community is excited. Science can learn more about the elements and circumstances that exist in other regions of our galaxy by examining things like Oumuamua. This may contribute to our knowledge of the elements' distribution throughout the Milky Way and provide hints regarding the possibility of extraterrestrial life and the existence of other habitable worlds. A visitor and messenger from outer space, Oumuamua holds secrets that could fundamentally alter our knowledge of the cosmos and excite scientists everywhere to anxiously anticipate the next interstellar discovery. Scientists have put up a number of intriguing theories on the nature and origins of Oumuamua, the first known interstellar visitor to our solar system, as we continue to explore this mystery. The hydrogen iceberg notion is among the more fascinating theories. According to this theory, Oumuamua could be a sizable block of frozen hydrogen gas. Oumuamua might be made of this unusual type of ice if it came from a much colder, farther-off region of the galaxy. The heat may have caused the frozen hydrogen to sublimate as it approached our sun, going straight from a solid to a gas. This would have given Oumuamua a slight push and increased its speed without the obvious tail that comets are known for. A different theory suggests that Oumuamua might be a piece of a bigger astronomical body. According to this theory, Oumuamua is similar to a piece of a cosmic puzzle that shattered off of an asteroid or planet in the distant past. This idea is supported by Oumuamua's fragmented character, which points to a turbulent past, including collisions or other disruptive events that would have propelled it out of its home star system and into ours. These theories are not without disagreements and difficulties, though. For example, the hydrogen iceberg theory has generated a great deal of debate. Critics contend that because of the extreme radiation and other unfavorable circumstances found in space, a hydrogen glacier moving through interstellar space would probably melt long before it reached our solar system. There is a great deal of disagreement among scientists over the possibility that such an object will survive the journey. In a similar vein, the hypothesis that Oumuamua is a piece of a larger entity begs the issues of precisely how and by what kind of cataclysmic event such a piece could have been ejected with sufficient force to travel from its home system to ours. The discussions surrounding Oumuamua highlight our continuous attempts to make sense of its enigmas in light of our present understanding of astrophysics. Each explanation pushes the bounds of science and preserves Oumuamua's genuine nature as a fascinating riddle among the many unanswered mysteries of the universe. NASA has released a startling update regarding Oumuamua, warning that it is currently headed unexpectedly back to Earth. The scientific community is surprised by this outcome because it was first thought that after passing close to the sun, Oumuamua was going to permanently exit our solar system. Oumuamua's homecoming has important and varied ramifications. First of all, it offers a once-in-a-lifetime chance to closely examine an object that is extrasolar in nature. More information on its chemical and physical characteristics is especially desired by scientists, since it may provide insight into the nature of interstellar space and the circumstances of other star systems. The peculiar form and path of the item may provide additional insight into the processes and occurrences that mold these roving celestial bodies. In order to follow and analyze Oumuamua as it gets closer, NASA and other space agencies want to use a combination of space-based observatories and ground-based telescopes. The idea of sending a probe to actually land on the object or perhaps meet it is also discussed. An expedition of this kind might yield priceless information regarding the structure and makeup of the object, possibly supporting or contradicting current hypotheses regarding its origin, such as the possibility that it is an alien technology, a hydrogen iceberg, or even a naturally occurring object like an asteroid or comet. In addition to providing a scientific opportunity, Oumuamua's return marks a critical turning point for worldwide cooperation in space exploration. Oumuamua presents a rare opportunity for scientists worldwide to watch and collect data because it will be visible from different locations on Earth. This might enhance our future tracking and analysis techniques for interstellar objects, offering crucial information in the event that an object of a comparable nature threatens Earth. Ultimately, Oumuamua's surprise return serves as a reminder of how much we still don't know about the cosmos and how unexpected discoveries can upend our understanding of it and our technological capabilities, inspiring both wonder and a frenzy of scientific investigation. When Oumuamua arrived, it not only altered our perception of what heavenly bodies could look like, but also altered their behavior. Oumuamua has broadened the focus of astronomical research and increased interest in locating and monitoring other similar objects as the first known interstellar visitor. This anomaly forced scientists to reevaluate accepted theories about the origin of the solar system and the classification of objects, since it showed that the universe is more surprising than our current models could have imagined. Several missions to conduct more in-depth studies of interstellar objects are being planned or envisioned in reaction to the mysteries revealed by Oumuamua. The Comet Interceptor mission, created by the European Space Agency, is one noteworthy project. In order to be launch-ready, this mission must be prepared to go into action as soon as the next interstellar object is detected. It seeks to confront these visitors head-on, collecting hitherto unheard-of data via close observation and analysis, something that Oumuamua's abrupt presence and quick departure precluded. Additionally, NASA and other space organizations are improving their networks for detection. Increasing the chance of finding interstellar objects while they are still reachable by probes is the aim. These improvements involve the creation of new sky-scanning devices, as well as updates to already existing telescopes. Astronomers anticipate that with these enhanced capabilities, they will be able to identify possible extrastellar guests earlier and send out exploratory missions fast enough to perform in-depth observations that will yield information on their composition, structure, and perhaps even their origins. Inspired by Oumuamua's discovery, studies and missions are expanding our knowledge of the universe and providing new perspectives on the dynamics of our galaxy and the intriguing potential of extraterrestrial life. Let's sum up by saying that Oumuamua's unexpected visit has sparked a new chapter in interstellar object research and significantly altered how we approach the study of these enigmatic extrasolar visitors. Oumuamua's transit through our cosmic neighborhood has spurred a number of programs and missions that seek to provide humanity with the information and resources needed to research and intercept future interstellar objects. These endeavors will not only augment our comprehension of the cosmos, but also deepen our understanding of the genesis of celestial bodies and the possibility of extraterrestrial life. With every new finding made while searching the skies, we get closer to finding the answers to some of the most important issues regarding our place in the universe.
We are looking for signs of life.
We have ignition and we have liftoff.
In the vast, silent expanse of space, a lone explorer travels further than any other human-made object in history. Launched in 1977, with a mission that was supposed to last just 5 years, Voyager 1 has defied all expectations, pushing the boundaries of human achievement and curiosity. For over 4 decades, it has been our silent ambassador to the cosmos, carrying messages from Earth to the unknown. But recently, something unexpected happened. This pioneer of space, now billions of kilometers from home, started sending back signals that have puzzled the brightest minds at NASA. What are these strange signals? Are we on the verge of a new discovery? Or is Voyager 1 revealing the limits of our reach? Stay tuned as we dive into the mystery of Voyager 1's latest messages from the edge of space. What will we learn from this distant traveler? And how much longer can we keep the conversation going before silence takes over?
The sun will have a fate such as this, where at the end its outer layers of gas will escape into space.
The summer of 1977. In the summer of 1977, an opportunity arose that comes once in a lifetime, or more accurately, once every 176 years. This was the year NASA embarked on one of its most ambitious missions, the Voyager program. It began with the launch of Voyager 2 on August 20th, a date that would mark the beginning of humanity's grand tour of the outer solar system. But the story doesn't start there. It was a culmination of years of planning, all leading up to a narrow window when the outer planets aligned just right. This alignment allowed a spacecraft to hop from one planet to the next using minimal fuel in what's known as a gravity assist or slingshot maneuver. It was an ingenious solution to an otherwise insurmountable distance problem. Just a few weeks after Voyager 2's departure, its twin, Voyager 1, followed suit. Though launched second, Voyager 1 was destined to travel faster and farther, thanks to its unique trajectory. Both spacecraft, nearly identical twins, were engineered to withstand the harsh conditions of space and equipped with instruments designed to study the planets they would encounter. Weighing about as much as a small car, these probes were the epitome of human ingenuity and the embodiment of our desire to explore. The significance of their launch timing cannot be overstated. This fortuitous alignment allowed Voyager 1 and 2 to embark on a path that would see them visit Jupiter, Saturn, and for Voyager 2, Uranus and Neptune, providing humanity with its first close-up views of these distant giants. This grand tour, made possible by the planetary alignment and the gravitational slingshot effect, would forever change our understanding of the outer solar system. It was a bold plan, one that would leverage every ounce of momentum and every bit of data the Voyagers could muster as they set out to the stars, carrying the sights and sounds of Earth on their golden records, hoping to share a bit of our world with whatever or whoever might find them. The early discoveries. As Voyager 1 hurtled through the cold void of space, it approached the gas giant Jupiter in 1978, marking the beginning of a series of groundbreaking discoveries that would forever change our understanding of the outer solar system. With its cameras trained on this behemoth of swirling gases, Voyager 1 embarked on an extensive study, capturing detailed images that unveil the intricate beauty and complex dynamics of Jupiter and its moons. It was during this close encounter that Voyager 1 made one of its first major discoveries, the faint, dusty rings of Jupiter, a feature previously unknown to scientists. These ghostly rings challenged our perceptions and showcased the diversity of planetary ring systems. But the surprises didn't stop there. Voyager 1's journey brought it closer to Jupiter's moons, revealing 2 previously unseen moons, adding new members to Jupiter's already impressive family. Each of these discoveries provided insights into the formation and evolution of the solar system's planets and their satellites, opening new avenues for research and speculation. The spacecraft's adventure continued as it set its sights on Saturn, the jewel of the solar system, with its magnificent rings and numerous moons. However, to get the best possible view and scientific data, Voyager 1's trajectory needed a critical adjustment. This maneuver was not just a testament to the precision and ingenuity of NASA's engineers, but also a necessary step to avoid a potentially mission-ending collision with Titan, Saturn's largest moon. As Voyager 1 completed its flyby of Saturn, it discovered 4 new moons, further expanding our knowledge of the Saturnian system. The spacecraft also sent back detailed images of Saturn's rings, providing an unprecedented look at their structure and composition. Interstellar mission commencement in 1990. In 1990, a remarkable shift occurred for Voyager 1, transitioning from a trailblazer of our solar system to an envoy to the stars. After its groundbreaking explorations of Jupiter and Saturn, this intrepid spacecraft embarked on a journey that would take it to the very edge of our solar system and beyond, into the vast, uncharted territories of interstellar space. This phase of its mission marked not just a continuation of its voyage, but a leap into the unknown, a testament to human curiosity and our insatiable hunger for knowledge. One of Voyager 1's most awe-inspiring contributions during this time was the capture of the family photo of our solar system. Positioned about 6 billion kilometers away from the Sun, it turned its camera one last time to take a series of images that would encapsulate the entirety of our home system in a single poignant frame. This mosaic of the planets, seen as mere dots of light against the vastness of space, offered a humbling perspective on our place in the universe, famously inspiring Carl Sagan to reflect on the pale blue dot that is Earth. Understanding the need to preserve its limited resources for the long journey ahead, NASA made the decision to turn off Voyager 1's cameras after this monumental task. This was a calculated sacrifice, trading the ability to visually document its journey for the chance to extend its life and continue sending back valuable data. This pivotal moment underscored the shift in Voyager 1's mission from observation to endurance, as it powered down its eyes and ventured into the darkness, guided by the hope of discovering the secrets of interstellar space. As Voyager 1 pressed forward, it continued to communicate with Earth, its signals traversing the vast distance to bring insights back to those of us waiting eagerly for any news from the frontier. The spacecraft, now a silent witness to the cosmos, continues to traverse the boundary of the heliosphere, the protective bubble that marks the edge of the Sun's influence. In doing so, Voyager 1 has not only expanded our understanding of the solar system, but has also begun to peel back the layers of the interstellar medium, offering glimpses into the composition and dynamics of the space between the stars. Exiting the solar system. By 2012, this intrepid explorer had done the unthinkable. It had officially exited the solar system, venturing into the mysterious realm of interstellar space. This monumental achievement wasn't just a milestone for the spacecraft, but a historic event for humanity, marking the first time a human-made object had ever left the solar system. The announcement made by NASA in 2013 sent waves of excitement and wonder through the scientific community and the world. Voyager 1's transition into interstellar space was not just a testament to human ingenuity and the thirst for exploration. It symbolized the breaking of celestial boundaries. Imagine, a spacecraft designed with technology from the 1970s had now become humanity's most distant messenger, floating in the vastness of space far beyond the influence of our Sun. This was no small feat. Crossing into interstellar space meant that Voyager 1 had moved beyond the heliopause, the boundary where the solar wind from the Sun is stopped by the interstellar medium, marking the edge of our solar system's influence. Voyager 1's journey into this unknown territory provides scientists with invaluable data about what lies beyond the protective bubble of our Sun's wind and magnetic field. But what does it mean to exit the solar system? It means that Voyager 1 is now in a place where the Sun's warmth and light do not reach, where the dynamics of space are governed not by our solar system, but by the galaxy itself. It's in a region where no spacecraft has ever ventured, sending back data from a place more remote than we had previously been able to explore. Every bit of information it sends us from this uncharted territory helps us understand more about the nature of the universe, continued communication and data transmission. Despite being engineered with a lifespan of only 5 years, Voyager 1 has shattered all expectations, continuing to serve as a vital link between the cosmos and Earth for over 4 decades. This achievement isn't just a testament to the spacecraft's design, but a beacon of human ingenuity and our unquenchable thirst for knowledge. Since its launch in 1977, Voyager 1 has been our eyes and ears, transmitting data across the unfathomable distance of interstellar space. As it ventured past giant gas planets and their mysterious moons, Voyager 1 relayed back to Earth stunning images and invaluable scientific data, reshaping our understanding of the solar system. Its journey has provided us with the first ever family portrait of our planetary neighborhood, a visual testament to our place in the universe. But Voyager 1's mission extends beyond mere observation. Embedded within its structure is the Golden Record, a time capsule intended for any potential extraterrestrial intelligence that might encounter the spacecraft. This record carries the sounds, images, and messages of Earth, a hopeful gesture of communication across the stars, strange signals, and current status. In the latest chapter of Voyager 1's epic saga, an enigma has emerged from the void. This seasoned Voyager has begun beaming back a series of strange, indecipherable signals, igniting a whirlwind of speculation and intrigue among the scientific community. These anomalous transmissions, unlike anything the spacecraft has sent before, have left NASA's top scientists scratching their heads, wondering about the nature of these cryptic messages from the edge of interstellar space. Despite the spacecraft's advanced age having far surpassed its expected lifespan, the antenna of Voyager 1 remains in a state of remarkable health, faithfully maintaining its connection with Earth. This enduring link across the cosmic ocean allows Voyager 1 to still receive and execute commands sent from its terrestrial handlers, a small but significant reassurance amidst the growing mystery. As these puzzling signals continue to arrive, NASA is doubling down on its efforts to decipher them. Are they simply the result of an unknown glitch in the spacecraft's aging systems, or could they be indicative of something more profound that Voyager 1 is experiencing in the uncharted territories of interstellar space? The implications are vast and varied, sparking intense discussion and research within the scientific community. The intrigue of Voyager 1's situation is heightened by its historical mission, which has already reshaped our understanding of the outer planets and the very nature of space beyond our solar system. Now, as it sends back these strange signals, it beckons us to look beyond our current understanding, challenging us to think differently about the universe and our place within it. The Golden Record. Amidst the cosmic silence, Voyager 1 carries with it a message from Earth, encapsulated within a gold-plated disc known as the Golden Record. This disc is not just a message. It's a time capsule, an interstellar greeting card designed to communicate the story of our world to extraterrestrial beings. Imagine a record player floating through space, carrying the very essence of humanity on its grooves. Crafted with meticulous care, the Golden Record holds over 35 sounds from Earth. These are not just random noises, but a carefully curated selection intended to depict life on our planet. From the haunting calls of humpback whales to the exhilarating sounds of a train passing by, each sound is a thread in the rich tapestry of life on Earth. But the Golden Record holds more than just sounds. It's also a visual archive containing 116 images of daily life on Earth. These images are a testament to our diversity and unity, showcasing the vastness of our landscapes, the complexity of our societies, and the simplicity of human moments. They depict who we are, what we look like, and how we live, work, and play. And then there's the music. Over an hour of Western pop music, alongside traditional music from various cultures around the world, forms a sonic bridge across the cosmos. This eclectic mix is a celebration of our artistic diversity, reaching out across the void in the universal language of melody and rhythm. Perhaps most poignant are the greeting messages from numerous former US presidents, translated into 55 different languages. This polyphony of human voices, extending a hand of friendship into the unknown, reflects our innate desire to connect, communicate, and understand challenges and the future of Voyager 1. As Voyager 1 continues its unparalleled journey through the cosmos, it faces an inevitable reality that challenges the very essence of long-distance space exploration. As it ventures further into the void beyond the sun's influence and into the cold expanse of interstellar space, the signals that once briskly traveled between Earth and the spacecraft now take longer, with messages averaging a 2-day journey each way. This increasing delay marks not just the physical distance, but also a growing gap in our ability to maintain a lifeline to humanity's most distant ambassador. This challenge isn't just about time, it's about the fragility of connection in the vastness of space. The further Voyager 1 gets, the more attenuated and precarious this connection becomes. There's a haunting realization that comes with this. Should something go wrong, there's no backup plan, no mission to repair or rescue Voyager 1. It's out there on its own, carrying on its mission in the silent vastness, reliant on systems designed decades ago. NASA, while hopeful, is pragmatic about the situation. The agency is pushing the limits of its ingenuity to keep the conversation going with Voyager 1, knowing all too well that each message received is a victory against the odds. The spacecraft's enduring silence could commence at any moment, not necessarily with a dramatic conclusion, but perhaps with the simple cessation of signals, leaving us to wonder about the fate of our most distant Voyager. This precarious situation underscores a broader theme in space exploration: the balance between the drive to explore further and the limitations of our technology. Voyager 1's journey is a testament to human ingenuity and a desire to explore the unknown. Yet it also serves as a reminder of the vastness of space and the limitations we face in our quest to understand it. As we continue to listen for Voyager 1's whispers from the depths of space, we stand on the brink of potential silence, a poignant reminder of the spacecraft's lonely journey and the vast, unexplored cosmos that lies beyond our reach. What do you think about this? We hope you found these facts intriguing. If you've heard them before or have any thoughts to share, please let us know in the comments below. Don't forget to give us a thumbs up and subscribe to A World to Discover to join us on our journey of discovery. While you're still here, feel free to click on other videos you will see on the screen right now.
Looks at going to the moon one day and to Mars, and to get to Mars, they're going nuclear.
Imagine a world in which we are no longer limited by space and can traverse the enormous cosmic distances that previously seemed unbridgeable. Imagine spacecraft traveling faster than the speed of light as they dart across the stars. a concept that piques our curiosity and fuels our desire to explore beyond Earth. Science fiction no longer exists in this domain. Scientists are about to make discoveries that could lead to travel faster than the speed of light. We are on the verge of transforming the fantastical into the real, capable of stretching the boundaries of space and time and exploring theoretical possibilities that defy basic physics.
They call the action, which is to do with the mass of the particle and the time and the distance, so you basically calculate these little quantities.
But how much closer are we really to crossing this last obstacle? To what extent is science fiction already becoming science fact? Imagine being able to travel through space faster than the speed of light by boarding a spacecraft that looks like it belongs in your favorite action film. Once limited to fiction, this ambition is becoming more and more true thanks to the idea of warp drives, a speculative idea that might completely change space travel. The fundamental tenet of this project is a daring rejection of one of the most widely accepted theories in physics. Einstein's claim that nothing can travel faster than the speed of light. In accordance with Einstein's theories of relativity, an object's mass increases exponentially as it gets closer to the speed of light and needs an endless supply of energy to move forward. Humanity has long been forced to travel across the vast reaches of space at the glacial rate of conventional propulsion because to this barrier, which appears to be insurmountable. This brings us to the Alcubierre drive, an idea that originated in physicist Miguel Alcubierre's academic endeavors rather than science fiction. Alcubierre put up a method that bends space-time itself rather than trying to exceed the cosmic speed limit, drawing inspiration from the visionary leaps of science fiction. Imagine compressing space in front of a spaceship and extending space behind it, all while enclosing it in a bubble of flat spacetime. By staying in a pocket of space unaffected by relativity, this manipulation allows the spaceship to travel ahead and ride the wave of warped spacetime at effective speeds faster than light. Unquestionably enchanting, the Alcubierre drive offers a ticket to the skies. However, there are many theoretical and practical obstacles in the way of turning an idea into reality. Because the drive needs exotic matter or negative energy, it operates at the edge of physics, where the existence of such materials is still up for debate. Furthermore, this innovative kind of transportation is beyond the reach of existing technology due to the enormous amounts of energy required to control space-time on this scale. Warp drive technology, in spite of difficulties, symbolizes human inventiveness and our unwavering desire to explore, signaling the beginning of star-crossing expeditions as a tribute to our boundless potential and the ever-expanding boundaries of knowledge. Historical leap, the Concorde and its legacy. The Concorde is remembered in the annals of aviation history as a shining example of human inventiveness and the relentless pursuit of breaking boundaries. This supersonic passenger plane accomplished exploits that were previously only found in science fiction, completely redefining what it meant to fly over the sky. The Concorde, with its streamlined appearance and powerful engines, cut the time it took for traditional jet travel in half and made far-flung continents accessible in just 3.5 hours from Paris to New York. Nevertheless, despite its grandeur and speed, the Concorde had many drawbacks. Its only options were over the ocean, far from populated regions where the noise may disturb people due to the loudness of its engines and the sonic booms it left behind. Its retirement was also a result of its high operational expenses and the financial difficulties of maintaining such speed for commercial travel. But Concorde's legacy stood untarnished, marking a significant turning point in the race to conquer the sky and push the envelope of what was thought to be feasible. Curiosity and inspiration from the Concorde caused humanity to turn its attention from the skies to the stars, where they began investigating warp drives and space-time bending in an attempt to conduct interstellar travel, pioneering faster-than-light travel. Humanity is on the verge of making science fiction's fantasies a reality through our mission to colonize the vast reaches of space. Science and fantasy alike have long been enthralled with the notion of warping space and time itself to accelerate our craft faster than the speed of light in the cosmos. Experts in theoretical physics are now closely examining this idea, which looks like it could have been lifted from a science fiction book. It's amazing to see how the world of science fiction has impacted and inspired actual scientific investigations into the viability of warp drives. Interstellar travel has become a reality thanks to shows like Star Trek and the imaginative writings of authors like Gene Roddenberry and John W. Campbell. These works have also introduced the concept of the warp drive, a fantastic engine that can propel a spaceship faster than the speed of light to a wider audience. What was previously only a whimsical thought in the minds of artists has now provoked serious debates and theoretical investigations within the scientific community. In the 1990s, physicists began to view the ideas outlined by Einstein's theories as puzzles to be solved or opportunities to be taken advantage of, rather than as impassable obstacles that would never be overcome. This marked the beginning of the move from fiction to theoretical possibility. The difficulty was obvious. Could we not figure out a method to bend space-time itself, making shortcuts that would let us jump across cosmic distances in the blink of an eye, given that nothing can move faster than light within it? This bold inquiry has sparked an intriguing voyage of exploration that is expanding our knowledge of the cosmos and our role in it. Combination of science fiction, creativity, and modern research in the field of faster-than-light travel blurs the boundaries between the feasible and the impractical, bringing us one step closer to fulfilling the dream of space travel. Warp drive, from fiction to theoretical possibility. The transition from fiction to theoretical potential in the field of space travel frequently starts with an imaginative spark kindled by the stories we tell. Science fiction was full of ideas like warp drive, which imagined a time when people could travel across space faster than light and even faster than the speed of sound. Once limited to the pages of books and movie screens, this concept has drawn interest from scientists and grown into a ray of hope for intergalactic travel. How do we overcome the colossal barriers that stand in our way is just as important as can we when it comes to the task of traveling faster than the speed of light. Undoubtedly, energy is the most critical of these impediments. The speed of light is the ultimate speed limit of the cosmos according to the equations governing modern physics, which are based on Einstein's theories of relativity. According to our current understanding of physics, an endless amount of energy would be necessary to push an item at the speed of light, a frightening prospect that puts such undertakings in the realm of the impossible. Nonetheless, scientists are starting to look for answers on the outer edges of theoretical physics after being motivated by the creative leap of science fiction. There is some hope in the warp drive hypothesis, especially in the model put forth by physicist Miguel Alcubierre. Rather than challenging Einstein's speed restriction, Alcubierre's model suggests a workaround. If space travel isn't possible at a faster speed than light, then perhaps space can be made to move. A warp bubble that propels a spacecraft at essentially faster than light speeds might theoretically be created by shrinking space in front of the vehicle and expanding it behind. Negative energy or negative mass, which are not present in nature and whose very presence is considered exotic, is needed for this approach of bending space. The obstacles to developing a warp drive are enormous and go beyond energy needs to include the technical difficulties of modifying spacetime itself. How can the negative energy needed to create a warp bubble be produced and controlled? Which substances are resistant to the strains involved in this kind of operation? Crucially, how can we guarantee the viability and safety of traveling faster than the speed of light for the cosmos as a whole, as well as the courageous individuals aboard these cutting-edge ships? The distinction between science and fiction becomes increasingly hazy as we go across space, as evidenced by the development of the warp drive from theoretical concept to working machine, the Alcubierre drive, and beyond. Miguel Alcubierre, a physicist, came up with the intriguing theoretical idea of the Alcubierre drive, which would bend space-time itself and send humanity rocketing into far-off stars almost instantly. It's like riding waves of space-time, only instead of traveling through space, we can change space itself, making it possible for us to travel faster than light and across great distances. But even as the prospect of interplanetary travel shines brightly in our eyes, there are great obstacles in our way. The most difficult riddle: the amount of energy needed. According to theoretical calculations, producing the warp bubble would require mass and energy comparable to that of Jupiter, which is an enormous undertaking that beyond both our existing technological capacities and physics knowledge. Furthermore, the drive is predicated on the presence of negative matter, a material whose repellent gravitational qualities defy common sense. Although the theoretical foundations of negative matter provide some optimism, its elusiveness has kept it just out of reach for science, existing only in the intricate mathematical formulas of theoretical physics rather than in observable reality. The universe's boundless potential is revealed as scientists negotiate the challenges of warp drive technology and the hunt for negative matter on this difficult but inspiring adventure to revolutionize space travel. Innovations in warp drive research. Eric Lentz and Harold White have made significant contributions to the dynamic field of warp drive research, which is devoted to connecting science fiction and reality. Using solitons, self-maintaining warp bubbles. Dr. Lentz, a theoretical physicist at the University of Göttingen, presents a novel approach to traveling faster than light. This method avoids the traditional requirement for exotic matter and instead suggests a workable solution powered by positive energy densities already within our reach. In the meantime, the Limitless Space Institute is led by Dr. Harold Sonny White, a former NASA employee who has played a key role in advancing the theoretical idea of warp drives toward real-world testing. The finding by Dr. White of naturally occurring small warp bubbles in the Casimir cavity, which is formed by pressing two metal plates together in a vacuum, suggests that it may be possible to enlarge these structures to a size suitable for use in space exploration. This finding not only validates the warp drive theory, but also provides fresh directions for future investigations into the creation and manipulation of these warp bubbles. Dears, Lentz and White are making great strides toward enabling access to the stars through inventive physics and engineering with their groundbreaking work in warp drive development, which is closing the gap between the ideals of interstellar exploration and reality. Reality check. Our current capabilities. The boundaries between the realistic and the fantastical are frequently blurred in the field of space exploration, particularly when discussing the idea of traveling through space at warp speed, a notion that was previously only seen in science fiction books. We are captivated by the idea of reaching the stars during our lifetimes by surpassing the speed of light, the cosmic speed limit. For the time being, though, let's return to the present and the enormous, incomprehensible stretches of space that confront us, pushing the boundaries of our technical capabilities to the absolute maximum. The Parker Solar Probe, our fastest spacecraft to date, reaches an astounding 700,000 kilometers / a small fraction of the speed of light. To put this into perspective, it would take more than 6,500 years to travel to Proxima Centauri, our nearest star neighbor, even at this astounding speed. We imagine speeds that can exceed the speed of light when we discuss warp drives and folding space, which would enable us to travel across galaxies in an instant. However, the sobering truth of our current state of affairs presents a different image. Not only is the immensity of space intimidating, but it also serves as a sobering reminder of our small place in the cosmos. The distances involved are enormous, mind-boggling, not simply huge. Furthermore, our most sophisticated rockets and probes hardly even scrape the surface of the cosmic ocean, despite the tantalizing prospect of warp drive shortcuts presented by our theoretical models of spacetime. This sobering reality check is supposed to strengthen our commitment rather than lower our spirits. Every generation builds on the foundations set by the one before it, pushing the envelope of what is possible even farther. With aspirations of traveling faster than the speed of light, we stand on the shoulders of giants today and gaze out into space. However, it's crucial to keep in mind that the slow, sometimes agonizing advancements in knowledge and technology are what set us on our path to the stars. We pay tribute to our current space pioneers who, with every tiny but important step, overcome obstacles to bring the far stars within reach, bringing in a new period of unheard of growth, creativity, and discovery as we look forward to the days of warp drives and interstellar travel. Mars, humanity's next frontier. Looking beyond Earth, Mars represents the next great step forward for humanity on its cosmic voyage. Scientists, dreamers, and adventurers have all been enthralled with this mysterious crimson planet, shrouded in mystery and charm. In addition to being a monument to human tenacity and inventiveness, our mission to colonize Mars serves as a link to comprehend our place in the cosmos. The narrative of nations keen to leave their marks on space exploration history is one of victories and losses along the way to Mars. In an effort shrouded in secret, the Soviet Union was the first to reach out toward Mars. Despite its great ambitions, the Mars 1 mission ended in quiet when contact was lost. However, this did not dampen the spirit of inquiry. After it came Mars 2 and Mars 3, which, despite the latter's brief communication, were humanity's first visits to the Martian surface. In the present day, the terrain of Martian exploration is a patchwork of global endeavors. With the help of its Curiosity and Perseverance rovers, the United States has shed light on Mars geology and the possibility of extraterrestrial life. Equipped with state-of-the-art tools, these pioneering mechanical people navigate the Martian landscape and reveal mysteries that have been hidden for ages. Europe has also turned its attention to Mars, joining forces with Russia to launch the ExoMars mission with the goal of deciphering Martian methane and any biosignatures. The mission highlights a global desire to reach beyond our earthly bounds, even in the face of geopolitical tensions and the challenging conditions of space travel. The story of Mars exploration embodies the human spirit's unwavering quest for knowledge and our ability to dream big, as it captures the evolution of international rivalries into partnerships, technological achievements, and the indomitable human spirit. Soviet Union's secret success and the race to Mars. A covert race to the stars took place in the midst of the Cold War, out of the public sight. Driven by its spirit of innovation in space research, the Soviet Union set out on a quest that would subtly leave its mark on the history of interplanetary exploration. The Soviet Union had the audacity and the covertness to aim higher, towards the red soil of Mars, while the rest of the world was focused on the Moon. A significant, though little known, chapter in space history began in 1971. For the first time ever, a successful landing on the Red Planet was accomplished by the Soviet spacecraft Mars 3. There was, however, hush surrounding this incredible achievement. The expedition was decided to remain secret when the probe, having only communicated data back to Earth for a few seconds, failed due to the harsh Martian environment. The Soviet Union had anticipated a success that would eclipse the American moon landings, but instead, they witnessed a quiet victory that was only acknowledged by a select group of people in the upper echelons of Soviet politics and science. This covert accomplishment highlighted the fierce rivalry that defined Cold War-era space exploration. Every superpower desired scientific advancement as much as the enhanced geopolitical status that accompanied every significant space exploration achievement. While not as well known as their American counterparts, the Soviet Mars missions demonstrated a strong dedication to expanding human knowledge and capabilities. However, the quiet surrounding the Soviet Union's Martian experiments also reflected the larger character of the space race, which was characterized by amazing achievements made in the shadow of competition. The Soviet Union's covert Mars mission revealed a new chapter in space exploration history, offering a platform for not just rivalry, but also exploration and amazement beyond our planet's boundaries. The enduring legacy of the covert Cold War Mars missions demonstrates human ambition and curiosity, serving as a constant reminder of the infinite potential of space and motivation for our ongoing exploration of the unknown. The future of interstellar travel and Mars colonization. The prospects for interstellar travel and Mars settlement are endless as we approach the dawn of a new age in space exploration. The greatest minds in theoretical physics are currently delving into the unrelenting quest for faster-than-light travel, which was formerly limited to science fiction books. Visionaries such as Miguel Alcubierre have promoted the idea of bending space-time to our whim, which offers an alluring portal to the stars. Researchers like Durst, Eric Lentz, and Harold Sonny White are working hard to make the warp drive a reality, and it is no longer just a sci-fi fantasy. These developments portend a time when light-years-long travel distances could be completed in the blink of an eye. Concurrent with the aspiration to surpass the speed of light is the grand project of settling on Mars. For many years, the Red Planet has captured the attention of people because to its bleak beauty and possibility of fresh starts. In addition to offering priceless insights into the temperature, geology, and possibility of life on Mars, recent missions have established the foundation for human habitation. The combination of private companies like SpaceX, led by Elon Musk, and international space agencies is driving the dream of Mars colonization ahead. Musk hopes to establish a long-term human presence on the planet during our lifetimes. This joint effort represents a cosmic giant leap for humanity, similar to the evolution from hunter-gatherer tribes to agricultural civilizations. Still, the trip to Mars is only the start. The possibility of exploring space beyond Mars and into the larger galaxy is becoming more and more realistic as our knowledge of science and technology advances. The finding of exoplanets in habitable zones around far-off stars has created new opportunities for research and possibly even habitation. These celestial bodies might provide new places for humans to live, assuring our survival and the continuance of our galactic exploration and learning endeavors. In conclusion, the prospect of Mars settlement and interstellar travel serves as a constant reminder of our enduring urge to explore the unknown, in addition to serving as a monument to human creativity and tenacity. The opportunities are endless as we approach the edge of this new territory. The stars are lighthouses pointing us in the direction of our destiny amid them, not merely spots of light in the night sky. Although the road ahead is full of obstacles, we approach it with hope and the unwavering spirit of discovery that makes us who we are. Not on Earth, but in the dusty red soil of Mars and beyond, into the wide, unexplored reaches of our cosmos,
lies the next chapter in the history of humanity.
NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
The universe is a vast and awe-inspiring place, and although Earth is an incredible planet, it is just a tiny speck in the grand scheme of things. With the advancement of technology, humans have been able to launch rockets and satellites into space, leading to an insatiable thirst for knowledge about the mysteries of the universe. While we have a decent understanding of how the universe works, much of our information is based on conjecture and speculation. That's why space probes like Voyager 1 and Voyager 2 are so crucial to our comprehension of the cosmos. These probes are beaming back real-time data, shedding light on the farthest reaches of our solar system and interstellar space, which we may not be able to visit for many years to come. But what happens when this data includes a terrifying warning that changes everything we thought we knew about the universe? Join us as we delve into what Voyager has discovered so far and the unsettling message it has sent us about the future. For nearly half a century, the Voyager missions have been at the forefront of space exploration, providing invaluable insight into the mysteries of our solar system. It's hard to believe that these missions were not intended to last this long, given the wealth of information they have yielded. The story of how the Voyager program came to be is a fascinating one. It all began with a fortuitous discovery by Michael Minovich, who realized that a spacecraft could use the gravity of a planet to slingshot further into space. This led to the launch of Voyager 1 and Voyager 2 in 1977, with the aim of studying Jupiter and Saturn. What followed was nothing short of a miracle. Both Voyagers are equipped with 3.7-meter radio dishes and 16 thrusters to adjust their orientation and direct their dishes towards Earth. Their engines use hydrazine fuel, and their electronic components are powered by plutonium-fueled thermoelectric generators. Both carry 11 scientific instruments, half of which were designed to study planets and have since been turned off. The grand tour of the 4 planets has now become a remarkable achievement in human exploration. Voyager 2 successfully completed the first-ever close observations of Uranus in 1986 and Neptune in 1989, while Voyager 1 overtook Voyager 2 a few months after launch, passing Jupiter in 1979 and Saturn in 1980, and has become the farthest distant artificial object from Earth. While Voyager 2 still has 5 functioning instruments, Voyager 1 only has 4, but they both remain crucial for gathering valuable data on the deep reaches of space. Today, the 2 spacecraft continue to journey beyond the Sun's influence and into interstellar space, sending back valuable data on the cosmic environment. Before delving into the messages received from Voyager 1, let's first look into some of the discoveries and things both the Voyagers encountered along the way. Imagine embarking on an epic journey to explore the uncharted depths of our solar system with 2 trusty spacecrafts as your companions. Your first mission? Take a closer look at the mighty Jupiter and Saturn systems. And boy, did those probes deliver! They transmitted a plethora of never-before-seen images and gathered extensive data, completely revolutionizing our understanding of these gas giants and the iconic ringed planet. But while Voyager 1 bid adieu to our solar system and ventured into interstellar space, Voyager 2 still had some exciting pit stops in store. In 1981, a corrective maneuver was made to set Voyager 2 on a course towards Uranus. And after exceeding its originally predicted lifespan twice, the spacecraft finally arrived at the remote ice giant in January 1986. But that was just the beginning. On its way to Uranus, Voyager 2 discovered 10 previously unknown moons, adding to the growing celestial family. But the ultimate destination was Neptune, where Voyager 2 captured more than 9,000 images and made an incredible discovery: 9 previously unknown moons. But that wasn't all. Triton, the largest of Neptune's moons, had some fascinating secrets to reveal. It turns out that Triton's diameter was not as previously thought, and the satellite had surprisingly few impact points on its surface. And its brown-white coloration? Geysers. These volcanic formations spew out liquid nitrogen that freezes into white nitrogen snow upon landing on the surface. With these incredible discoveries, the Voyager mission left an indelible mark on our understanding of our cosmic neighborhood. No other spacecraft has revisited Uranus and Neptune after Voyager 2's journey. However, scientists have still been able to observe and study incredible phenomena on these planets from afar. And now, get ready to be amazed as we reveal the secrets of these mysterious spectacles. Uranus. When it comes to ice giants in our solar system, the list is pretty short with only 2 members, Uranus and Neptune. Despite the name, the majority of these planets' material is not actually frozen, but instead consists of hot, supercritical fluids made up of volatile chemical compounds like water, ammonia, and methane. It's a state of matter that combines the properties of liquids and gases. At an average solar distance of 1.8 billion miles, Uranus is the second outermost planet in our solar system, and its diameter is over 4 times that of Earth. It takes Uranus about 84 years to orbit the Sun, and during that time it does something strange. It appears to be lying on its side. The reason for this peculiar axis inclination is unknown, but scientists think it may have collided with a large protoplanet early on. This could also explain the 27 moons orbiting Uranus, which may have formed from the debris of the collision. And if that's not enough to intrigue you, a massive white spot was discovered on Uranus's upper atmosphere about 10 years ago thanks to the Hubble Space Telescope. It turned out to be a gigantic storm whipping around at speeds of up to 89 miles per hour, larger than the United States. But if you think that's wild, imagine the freezing temperatures of Uranus's methane and ammonia clouds, which can drop to a chilling minus 323 degrees Fahrenheit. And don't forget, just like Saturn, Uranus has its own ring system, although it's much sparser and less abundant. Neptune. In 1846, a bluish shimmering planet was added to the star charts, and we named it Neptune. This outermost planet of our solar system is nearly 3 billion miles away from the Sun, making it quite the loner. To put that in perspective, the distance between Earth and the Sun is only about 90 million miles. Despite its distance, Neptune is similar in size to its ice giant neighbor Uranus, with a diameter of 31,000 miles. However, in terms of mass, Neptune takes the cake with a whopping 17 Earth masses compared to Uranus's 14.5 Earth masses. Neptune takes a whopping 165 years to orbit around the Sun, but it spins quite quickly on its axis, taking only 16 hours to complete one rotation. When NASA's Voyager 2 spacecraft visited Neptune in 1989, it captured some wild weather phenomena such as bright bands of clouds in the atmosphere and storms that reached top speeds of up to 1,305 miles per hour, the fastest winds observed on any celestial body. Experts believe that the lack of solar energy reaching Neptune allows these storms to whip up to such incredible speeds, but there is a chance they may disappear into thin air one day. During the Voyager 2 mission, scientists discovered the Great Dark Spot, a massive formation as large as Eurasia that was believed to be a hole in the planet's visible cloud cover. However, when scientists attempted to find the spot again a few years later, it was nowhere to be found. Some theories suggest that heat from Neptune's core caused turbulence in the atmosphere and tore the structure apart. Speaking of Neptune's core, despite the volatile nature of this planet, scientists believe it has a massive heart. The core is estimated to be 1 to 1.5 Earth masses and composed of metal and rock, with temperatures likely reaching nearly 13,000 degrees Fahrenheit and pressures estimated at several million bar. The magnetic fields of Uranus and Neptune have been a source of wonder for scientists for a long time. These invisible forces have a peculiar characteristic. They are tilted towards the rotation axis and deviate significantly from the planet's physical center. No one has yet unraveled the mystery behind these curious alignments. One thing that is certain, is that Neptune's magnetic field is 27 times stronger than Earth's. On the other hand, Uranus's magnetic field is surprisingly weaker than our home planet's. Experts believe that the magnetic fields of these gas giants are generated by movements in comparatively small depth, possibly caused by ionized water. But that's not the only secret that lies within these planets. It is widely believed that Uranus and Neptune have massive cores surrounded by dense layers consisting of hydrocarbons, ammonia, and water. Scientists have been intrigued by the incredible processes that might be happening under the immense pressures at the center of these planets. One fascinating theory suggests that diamonds are raining inside Uranus and Neptune. This idea, which was once merely a thought experiment, was actually proven by a group of researchers a few years ago. The team used polystyrene, a plastic made up of hydrogen and carbon atoms, to recreate the extreme pressure conditions inside the ice giants. They sent 2 shock waves through the substance to see whether the hydrocarbon compounds would split under such pressure. The experiment generated a pressure of 1.05 million bar and raised the thermometer to a scorching 9,000 degrees Fahrenheit. The result was an astonishing shower of glittering diamonds, as nearly all the carbon atoms joined together to form tiny diamond structures. The diamonds that form in Uranus and Neptune would be much larger than those simulated in the laboratory. After they are created, these cosmic gems sink gradually towards the planet's core over a period of thousands of years. The thought of diamond rain on other planets is truly mind-boggling and adds to the intrigue and fascination of these mysterious gas giants. Over the past decade, the 2 probes have ventured into a vast and mysterious region known as the interstellar medium, the space between stars filled with sparse material. And they're still uncovering new discoveries. One of the most surprising findings is the strength and direction of the interstellar magnetic field, which has sparked lively debates among experts about the shape and activity of the Sun's magnetic domain, the heliosphere. Previously thought to be shaped like a comet, the heliosphere may actually be more spherical. And what happens to the heliosphere when sunspots appear and disappear? The spacecraft has provided some intriguing clues. When the solar wind, a flow of charged particles emanating from the sun, comes to a halt, it marks the beginning of the interstellar medium. This ionized gas or plasma is like a rock in a river, pushing against the cooler, denser plasma flowing around it. The sun-carved cavity that forms is called the heliosphere, with its edge called the heliopause, similar to how the top of Earth's troposphere is called the tropopause. Don Gannett, a University of Iowa researcher who worked on the Voyager mission, says that when the spacecraft launched, they had no idea how far the heliopause was. Some speculated it could be as close as Jupiter, which is only 5 times further from the Sun than Earth. But as Voyager ventured further, estimates of the heliopause's distance increased, ruling out Jupiter, Saturn, Uranus, and Neptune. No one knew when or where the spacecraft would enter interstellar space. According to Don Gurnett, shortly after Voyager passed by Neptune, it detected signs of the heliopause in the distance. The spacecraft picked up strong radio waves between 2 and 3 kilohertz in July of 1992, which were later attributed to 6 significant flares on the Sun that occurred over a year prior. The researchers found that the plasma from the flares eventually made its way to the heliopause, where it caused electrons to oscillate and release radio waves. The frequency of these radio waves implied a density matching that expected for the interstellar medium, revealing that the local interstellar medium is far denser than the outer heliosphere. Despite appearing like a pure vacuum on Earth, it is actually quite tenuous. By calculating the speed of outbound solar material and the time it took to hit the boundary, the distance of the heliopause from the Sun was revealed to be between 116 and 177 astronomical units, providing a fascinating insight into our solar system's outer boundaries. When Gannett claimed that Voyager had detected radio waves at the heliopause, he was met with skepticism from many scholars. Not only were these radio waves unprecedented, but Gurnett's interpretation of them also suggested that the heliopause was located at a significant distance from the Sun. To put this into perspective, the distance between the Sun and Neptune is just 30 astronomical units, while the heliopause seem to be much farther away. Despite these doubts, Voyager 1 successfully crossed the heliopause at a distance of 121.6 astronomical units, consistent with Gurnit's prediction. However, due to the controversy surrounding the claim, NASA decided to delay the announcement of the accomplishment for over a year, although Voyager 1 did observe some indications that it had left the heliosphere, such as a decrease in high-energy particles from the Sun and an increase in cosmic rays from beyond the solar system. Many researchers were still not convinced. One issue was that Voyager's plasma instrument had stopped functioning, making it impossible to measure the sudden increase in particle density that occurs when leaving the heliosphere. Additionally, it was expected that the magnetic field would point in a different direction beyond the heliosphere, but this did not happen. Even today, scientists are still scratching their heads trying to explain why the magnetic field outside the heliosphere aligns with the magnetic field inside. It's a mystery that has yet to be solved. Voyager's incredible journey was partly aided by the Sun's outbursts. In 2012, massive solar storms stirred the plasma Voyager 1 traveled through, causing electrons to emit radio waves. These waves indicated that Voyager had entered a denser region of space. On November 5, 2018, Voyager 2 also crossed the heliopause without raising concerns. Its plasma instrument recorded a significant spike in particle density and higher temperatures, likely due to plasma compression when entering the heliosphere. Like Voyager 1, Voyager 2 observed the disappearance of solar wind and an increase in cosmic rays, with an unchanged magnetic field. Stamatios Tom Krimiges of Johns Hopkins University noted that both spacecraft crossed at similar distances, despite different solar cycles in 2012 and 2018. The heliosphere, influenced by the waxing and waning of sunspots over an 11-year cycle, expands and contracts. Despite lower solar wind pressure in 2012 than in 2018, the similar distances suggest the heliopause is more resilient than previously thought. Despite the exact form of the heliosphere remaining a mystery, Voyager 1 and Voyager 2 continue to sail away from it. By the end of this year, Voyager 1 will be 155 astronomical units from the Sun, with signals taking over 22 hours to reach us. Voyager 2 will be 129 astronomical units away and is set to pass Pioneer 10 in late 2023 to become the second furthest spacecraft ever. These spacecraft are now further apart from each other than from Earth. In May last year, Voyager 1's Attitude Articulation and Control System, AACS, began sending confusing data. Despite this, the spacecraft remained in good shape, with a strong, steady signal indicating the antenna was still pointed at Earth. The AACS continued to experience issues, but the science systems functioned normally. NASA identified the problem as the AACS transmitting telemetry via a long-defunct onboard computer. Engineers instructed the AACS to use the correct computer, solving the issue. The next step is to determine what caused the system to switch in the first place. Although not a serious concern for Voyager 1's safety, identifying and correcting the fundamental cause is necessary to prevent future anomalies. In the vast expanse of interstellar space, Voyager 1 has been a true pioneer, journeying beyond the protective shield of our Sun's magnetic field for over a decade. Despite the hostile environment with high-energy particles and cosmic radiation bombarding the craft, Voyager 1 has continued to push forward, delivering valuable data and insights about the mysteries of deep space. According to Susan Dodd, the project manager for Voyager 1 and 2, strange occurrences like the recent AACS malfunction are expected in this groundbreaking mission. After 45 years of exploration, the Voyagers remain a testament to human ingenuity and determination. Let's hear your thoughts about the Voyager mission in the comments section below.
We have found a terrestrial planet orbiting Proxima Centauri. It's the nearest exoplanet we will ever find.
Astronomers are exploring the cosmos like never before, thanks to the advanced James Webb Space Telescope. This marvel of technology, which launched back in 2021, has sparked a new era of cosmic discoveries, notably concerning Proxima b, the closest exoplanet to Earth, located about 4.25 light-years away in the habitable zone of the star Proxima Centauri. Proxima b, a super-Earth in the habitable zone. Understanding Proxima b's tidally locked status, where one hemisphere perpetually faces the star while the other remains in darkness, raises intriguing possibilities about its climatic conditions and the survival strategies that might be necessary for any potential life forms or future human explorers. On Earth, life depends on a stable cycle of day and night to regulate environmental and biological rhythms. In contrast, the permanent daylight on one side of Proxima b could mean environments that are continuously warm and illuminated, while the opposite side might experience perpetual night and significantly cooler temperatures. This stark contrast could affect atmospheric dynamics dramatically, potentially creating extreme weather patterns as heat from the day side tries to circulate to the night side. For a technological civilization on Proxima b, managing these conditions could involve innovative infrastructures, such as vast networks of energy, transfer systems that harness and redistribute solar energy. One could imagine a civilization using advanced technology to create a balanced climate across the planet, perhaps utilizing superconducting cables that span the globe to distribute heat and power efficiently from the illuminated side to the dark side. Such scenarios also invite us to think about the types of technology necessary to detect and interact with such potential civilizations. Our current search with instruments like the James Webb Space Telescope and studies into artificial light could one day reveal signs of such advanced technological adaptations, offering us profound insights into the adaptability of life and technology under extreme conditions. Understanding Proxima b's unique environment not only expands our knowledge of planetary sciences, but also pushes the limits of our technological imagination, laying groundwork for the kind of interstellar engineering we might someday deploy in our own cosmic ventures. Thus, Proxima b stands not just as a subject of scientific inquiry, but as a beacon that challenges our ingenuity and resourcefulness in the face of stark, celestial extremes. Hints of civilization, detecting artificial light on Proxima b. The James Webb Space Telescope's capabilities have allowed astronomers to detect what might be artificial lights emanating from Proxima b. This observation is particularly intriguing because it suggests the presence of technology, possibly a form of advanced civilization. Imagine a world where night never falls on one side, and on the other, darkness prevails perpetually. It's here, on this eternally shadowed hemisphere, that we might be seeing lights that could be street lamps, buildings, or other manifestations of alien ingenuity, similar to how we light up our cities and streets. These lights are not just points of brightness. They could indicate complex energy usage and perhaps even a structured society capable of manipulating their environment significantly. If these findings are verified, this would mark the first time human technology has identified a potentially technologically advanced civilization beyond Earth. This not only expands our understanding of habitability in tight solar orbits, but also deepens the mystery surrounding these distant worlds. Such a discovery redefines not just the search for extraterrestrial life, but also the very parameters of what to look for in the cosmos. The implications of this could be profound, reshaping our search strategies and targets in the ongoing quest to find alien life. As we continue to investigate these signals, we edge closer to perhaps one day confirming the existence of other technologically advanced civilizations in the universe. Delving into Proxima b's atmosphere, the atmospheric study of Proxima b via the James Webb Space Telescope offers a rare window into conditions on a potentially habitable exoplanet. Given the high sensitivity of James Webb's instruments, astronomers can discern subtle variations in the planet's atmosphere, providing insights into its climate and chemical makeup. Proxima b's proximity to its star could lead to extreme atmospheric conditions, including high radiation levels and significant temperature variations between its day and night sides. This makes understanding its atmospheric stability and composition even more critical. Researchers focus on identifying key molecules like water vapor, carbon dioxide, and methane, which are considered essential for supporting life as we understand it. The presence of these molecules can indicate active geological or chemical processes similar to those on Earth, which could sustain an environment conducive to life. For instance, water vapor is a telltale sign of potential hydrological cycles, and methane could suggest organic activity. These detailed observations also help in modeling Proxima B's potential ecosystems and assessing how its environment has evolved over time. Are these conditions stable enough to support life? Does the atmosphere protect the surface from harmful stellar radiation? Each data point collected by the James Webb Space Telescope helps to build a more comprehensive picture of Proxima B's habitability. Ultimately, while the search for alien life is captivating, it is the meticulous study of atmospheres like that of Proxima B that grounds such searches in scientific rigor. This ongoing research not only enhances our understanding of distant worlds, but also refines our knowledge of planetary science, a critical step toward answering the age-old question of whether we are alone in the universe. The philosophical implications of discovering alien life. Exploring Proxima B transcends the scientific ambition of discovering alien life. It taps into a deeper, almost philosophical yearning that has shadowed humanity throughout history. This exoplanet, nestled in the habitable zone of the nearest star to our solar system, serves as a canvas on which we project our grandest existential inquiries. As astronomers pass through data collected by instruments like the James Webb Space Telescope, each piece of information offers a potential clue not just about the conditions on Proxima B, but also about the broader cosmic landscape that surrounds us. The implications of finding life or habitable conditions there are monumental. They would suggest that life-sustaining planets could be more common than previously thought, thereby increasing the probability that the universe teems with life. This prospect shifts our understanding of life's rarity and resilience, prompting us to reconsider our role and significance in the grand scheme of existence. Are we just a cosmic anomaly, or part of a broader, perhaps infinite tapestry of life forms? Such questions have philosophical weight, influencing everything from the search for extraterrestrial intelligence, SETI, to theoretical physics and existential philosophy. The study of Proxima B isn't just a quest for biological signatures or atmospheric analysis. It's a bridge to understanding the universe's capacity to harbor life, challenging our perceptions of loneliness and connectivity in the cosmos. In essence, as we decode the mysteries of Proxima B, we are also unraveling the narrative of human significance in an expansive, dynamic universe. The answers we find could redefine our place in the cosmos as not merely solitary travelers, but potentially as part of a much larger community of cosmic inhabitants. Breakthrough Listen, searching for signals of intelligent life. The Breakthrough Listen project, a pioneering initiative funded by ambitious visionaries, utilizes state-of-the-art radio telescopes to eavesdrop on the universe. Its primary goal is to capture electromagnetic signals that could indicate the presence of intelligent civilizations beyond Earth. Recently, their focus has turned toward Proxima B after detecting a narrow-band radio signal originating from its vicinity. This signal, peculiar due to its specific frequency pattern, closely resembles what we'd expect from a technologically advanced source. While it's far from confirmed as extraterrestrial, this development excites scientists and the public alike, as it may potentially shift our understanding of life in the universe. Each signal captured is rigorously analyzed to differentiate between possible interstellar communications and cosmic noise, ensuring that only the most promising are considered. This tantalizing glimpse into the cosmic landscape not only advances the field of astrobiology, but also deepens the enigma surrounding our nearest stellar neighbor. Such findings promise to catalyze further research, holding the potential to one day break the silence of the cosmos. Proxima B's rapid orbit and its environmental challenges. Proxima B's rapid orbit of just 11.2 days around its host star presents a unique dynamic when compared to Earth's annual journey around the Sun. This quick orbit implies that a year on Proxima B passes in what would be less than 2 weeks on Earth, drastically altering how we must approach the study of its seasons and weather patterns if such exist. given its potential tidal locking, where one side is perpetually day and the other eternally night. Understanding atmospheric circulation becomes crucial. Scientists hypothesize that if an atmosphere does exist, it could be the key to transferring heat between these two extremes, potentially allowing for a more temperate climate in the twilight zone between the harsh environments of the bright and dark sides. Such a study could offer insights into not only the climate and weather patterns on Proxima b, but also broaden our understanding of atmospheric sciences in extreme exoplanetary conditions. This could, in turn, deepen our knowledge of planetary habitability across the universe, revealing how life might adapt to conditions vastly different from those on Earth. Navigating the challenges of a hostile star. Exploring the habitability of Proxima b brings us face to face with the volatile nature of its host star, Proxima Centauri, an M dwarf. These stars, while abundant in our galaxy, present unique challenges for planetary habitability. M dwarfs are notorious for their violent solar flares, which can be much more frequent and powerful compared to those from our Sun. Such flares emit intense radiation that has the potential to strip away the atmosphere of planets in close orbits like Proxima b. This atmospheric stripping is critical because an atmosphere not only supports life as we know it, but also protects the surface from harmful cosmic and solar radiation. Further complicating the scenario, M dwarfs remain active longer than larger stars, meaning Proxima b is exposed to these harsh conditions for extended periods, potentially billions of years. This prolonged bombardment by solar radiation could hinder the development or sustainability of life, as continuous flare activity might prevent the planet from maintaining a stable atmosphere long enough for life to develop or sustain itself. Moreover, the high-energy particles from Proxima Centauri could erode the atmosphere's ozone layer if one exists, increasing the surface's exposure to deadly ultraviolet light. Without an ozone layer, any life forms would be vulnerable to radiation that could mutate DNA, posing another hurdle for life. These factors make the environment of Proxima b appear hostile. However, the resilience of life on Earth in extreme conditions gives us a glimmer of hope that life could adapt in ways we haven't yet imagined. Proxima b continues to captivate our curiosity and drive our exploratory efforts, each discovery bringing us closer to understanding not just other worlds, but also our own planet's resilience and the tenacity of life itself. Advanced tools for a deeper understanding. The James Webb Space Telescope, JWST, equipped with cutting-edge technologies such as the near-infrared spectrograph, NIRSpec, and the mid-infrared instrument MIRI, is revolutionizing our study of distant planets. These instruments are not just cameras or telescopes, they are finely tuned analytical tools that break down light into its spectral components. This process, known as spectroscopy, allows scientists to detect specific signatures of gases and other materials present in the atmosphere of Proxima b. NIRSpec, for example, operates in the near-infrared spectrum and can detect the faintest whispers of light coming from distant celestial objects. It analyzes the light that passes through or is emitted by a planet's atmosphere, capturing data that can reveal the presence of water vapor, methane, carbon dioxide, and other potential markers of life. This capability is vital because these compounds can suggest biological processes similar to those on Earth. MIRI complements NIRSpec by focusing on the mid-infrared spectrum, which is especially good for studying cooler objects in space. It helps astronomers study the thermal properties of Proxima b, including its temperature variations and heat distribution, which are crucial for understanding the planet's climate and weather systems. MIRI can also see through dust clouds that obscure other instruments, providing a clearer picture of the planet's surface and atmosphere. Together, these instruments provide a comprehensive view of Proxima b's atmospheric makeup and surface conditions, offering insights into whether the planet could support life as we know it. Each new piece of data brings us a step closer to understanding not just Proxima b, but the characteristics that make any planet potentially habitable. The ongoing research with JWST's instruments is gradually filling the gaps in our knowledge about Proxima b's environment, promising to eventually unlock the secrets of this intriguing world. A testament to human advancement in technology, the James Webb Space Telescope, JWST, stands as a monumental achievement in our quest to understand the cosmos. Equipped with a suite of sophisticated instruments, it peers into the farthest reaches of the galaxy with unprecedented clarity. This telescope uses infrared technology to bypass the dust and gas clouds that obscure other telescopes' views, allowing us to observe the formation of stars and planets in real time, examine the chemical composition of alien atmospheres, and possibly detect signs of life by identifying atmospheric anomalies that cannot be explained by natural processes alone. One of the most intriguing capabilities of the JWST is its potential to observe the atmospheres of distant exoplanets in such detail that we can identify the molecular signatures of water vapor, methane, and carbon dioxide. These molecules are often considered potential indicators of biological processes. By comparing these findings with our own planet's biosignature, scientists hope to uncover parallels that might suggest similar life-sustaining conditions elsewhere in the universe. This ability to look back in time and out across space provides a clearer picture of our own origins as well. By examining other solar systems at various stages of development, we gain insights into the past and future of our own planetary system. The James Webb Space Telescope not only expands our understanding of the universe, but also serves as a mirror, reflecting the possible trajectory of our own planetary destiny. With each mission and observation, JWST is rewriting textbooks on astronomy and possibly biology, bringing us steps closer to solving the ultimate mystery of our existence in this expansive universe. Expanding our cosmic horizons. The exploration of Proxima b transcends traditional astrophysics, venturing into philosophical realms as we ponder our place in the cosmos. Studying this exoplanet, particularly within its star's habitable zone, we confront the profound possibility of encountering extraterrestrial life forms. This endeavor not only sharpens our technological prowess, but also deepens our existential inquiries. By analyzing the atmospheric conditions and potential biological signatures on Proxima b, we contribute to a broader understanding of what environments can sustain life. Each discovery here influences our approach to other celestial bodies and adjusts our theories about life's prevalence in the universe, encouraging a broader reconsideration of biological possibilities beyond Earth. This ongoing research could eventually lead to a revolutionary paradigm shift in how we perceive life and intelligence in the universe. The journey of discovery continues. Now let's conclude. The exploration of Proxima b is not just a scientific endeavor, but a journey that taps into the human spirit of discovery, pushing the boundaries of technology, knowledge, and our understanding of life itself. As we peer deeper into the cosmos, each finding adds a new piece to the puzzle of our universe, ever expanding the horizons of human discovery.
When you get a solar flare, the level of charged particles can be so high, it can short-circuit the electronics of satellites when it reaches Earth.
Imagine witnessing the power of millions of nuclear bombs exploding simultaneously. That's the staggering energy released by a solar flare, nature's most magnificent and terrifying display. As the sun belches out these colossal bursts of plasma, we're reminded of our star's formidable power. In this video, we dive into the heart of solar flares with none other than astrophysicist Neil deGrasse Tyson, guiding us through the cosmos' fiery wrath. What happens when these cosmic giants target Earth? Are we prepared for the potential aftermath?
Scientists, some, are sounding the alarm on a so-called solar superstorm that could, and this is important, eventually wipe out the internet for weeks or even months.
Understanding solar flares. Solar flares stand as colossal explosions on the sun's surface, far from being mere flickers or insignificant bursts. These events represent moments when immense amounts of magnetic energy are converted into heat, light, and a spectacular expulsion of particles. To grasp the scale of energy unleashed during a solar flare, imagine the simultaneous detonation of millions of nuclear bombs. This comparison, while staggering, actually captures the magnitude of energy released in the process. The extraordinary energy from a solar flare doesn't just vanish into the cosmic void. Instead, it has the potential to reach Earth, affecting our technological infrastructure, the planet's atmosphere, and possibly even altering our way of living. But what triggers these powerful solar outbursts? The genesis of solar flares lies deep within the sun's core, amid the chaotic dance of magnetic fields. In this volatile realm, magnetic lines of force undergo realignment, releasing energy on a scale that is hard to comprehend, giving birth to what we witness as solar flares. The impact of these solar explosions extends across the solar system, sending a flux of energetic particles in Earth's direction. These events underscore the immense power of our closest star and its profound influence on our everyday life and the fragile equilibrium of our planet. As observers of these celestial spectacles, often likened to solar fireworks, we are constantly reminded of the delicate balance that enables life to flourish on Earth under the watchful gaze of our ever-dynamic sun. The sun's red giant phase. In the distant future, a monumental transformation awaits our sun, marking a pivotal moment in the vast timeline of the cosmos. This future phase, known to astronomers as the red giant phase, heralds a significant shift in the sun's existence and spells a dramatic conclusion for life on Earth. During this period, our sun will undergo a dramatic increase in size, expanding to engulf the inner planets of the solar system, including our own planet, Earth. As the sun depletes its nuclear fuel, it is set to grow to a gargantuan scale, ballooning to hundreds of times its current diameter. Its outer layers will stretch out, reaching the very orbit of Earth, bringing about profound and unimaginable changes to our home planet. The intensifying heat and radiation from the sun, now a vast and all-consuming giant, will lead to the boiling of Earth's oceans, which will evaporate and vanish into the void of space. The Earth, once a vibrant blue orb teeming with life, will be transformed into a desolate, barren rock, devoid of any life-sustaining water. This cataclysmic transformation will signify the end of the Earth's capacity to harbor life. The planet's atmosphere will be gradually stripped away, leaving its surface exposed to the scorching effects of the sun's radiation, turning it into nothing more than a scorched wasteland. This inevitable phase in the sun's life cycle serves as a stark reminder of the transient nature of celestial bodies and the ultimate destiny that awaits our planet. It underscores the profound impact of cosmic evolution on the fate of Earth, highlighting the impermanent nature of our world in the grand scheme of the universe. The Carrington Event, a historical perspective. In the midst of the 19th century, humanity stood witness to an extraordinary cosmic phenomenon that profoundly influenced our burgeoning technological landscape. This event, now known as the Carrington Event, occurred in the late summer of 1859, marking a significant milestone in the annals of space weather research. It derives its name from Richard Carrington, a dedicated British astronomer who meticulously documented the solar flare that was at the heart of this unprecedented event. On an unremarkable day, amidst his regular observations, Carrington observed an intense white light erupting from the surface of the sun. This was not merely a spectacle of light and energy, it was the harbinger of an immense geomagnetic storm that would reach Earth about 18 hours later. This storm unleashed a magnetic wave across our planet, the likes of which had never been documented in the annals of human history. The effects of this geomagnetic storm were both immediate and profound, particularly on the telegraph systems of the time. These systems represented the pinnacle of communication technology in the mid-19th century, but they were ill-prepared for the solar storm's impacts. Telegraph operators were startled by papers catching fire, machines functioning without any external power, and electric shocks that rendered the telegraph network erratic or, in some cases, completely inoperative. This event served as a stark reminder of our technological vulnerabilities and the potential havoc that solar activity can wreak on human advancements. Modern dangers of solar flares. As we delve deeper into an era where technology is not just a part of our lives, but the foundation upon which our modern society is built, the shadow of solar flares looms larger and more ominously than ever before. These natural phenomena, eruptions of immense energy from the sun, pose a significant threat to the technological infrastructure that underpins our way of life. Envision a scenario where our world is plunged into darkness, not just momentarily or for a few hours, but for an extended period that stretches into days, weeks, or possibly even longer. This scenario is not plucked from the pages of a science fiction novel, but represents a real and present danger in our technologically dependent age. The electrical grids, the lifelines of our civilization, are alarmingly susceptible to the destructions caused by solar flares. A substantial solar flare could unleash electrical currents powerful enough to destroy transformers and incapacitate power stations, casting vast swaths of civilization into an unwelcome return to darkness. The risks extend far beyond the vulnerabilities of our terrestrial infrastructure. The skies above, crowded with satellites, are integral to nearly every facet of modern life. from navigating our way through cities to the seamless flow of global communications. These satellites are at peril from the intense burst of energetic particles from solar flares, which can wreak havoc on satellite electronics, disturb the transmission of signals, and cause deterioration to these critical orbital assets. The potential for a domino effect of failures is real, with consequences that could cascade through every corner of our economy, disrupt emergency services, and affect many other critical aspects of our daily lives. Furthermore, our global communication networks, the very threads that weave together the fabric of our interconnected existence, stand on precarious ground. The impact of a solar flare could instantly sever these connections, disrupting the flow of information and communication on which we have become so dependent. A recent incident, a significant solar flare causing a moderate radio blackout over South America, starkly illustrates our system's vulnerability. Such events underscore the precariousness of our reliance on technology, highlighting how quickly our capabilities for communication, navigation, and digital operation can be disrupted. In this light, solar flares represent not just a natural curiosity, but a formidable challenge to the resilience of our technological society, reminding us of the need for preparedness and protection against the caprices of our sun. Solar observations and advances in astronomy. In the vast expanse of our universe, the sun has always been a focal point of human curiosity and scientific inquiry. Our journey into the realm of solar astronomy began in earnest in the early 18th century, when astronomers first turned their telescopes towards the heavens, not just to map the stars, but to study our own star's enigmatic and vibrant nature. This was a time when the field of solar astronomy was as straightforward as it was daring. Armed with nothing but their telescopes and the naked eye, early astronomers began to peel back the layers of the sun's blazing facade. The sun, a seemingly eternal flame in the sky, revealed its secrets slowly. By simply observing its light, early scientists learned volumes. They used prisms to dissect the sunlight into its many wavelengths, unveiling a spectrum that stretched from the ultraviolet to the visible and into the infrared. They discovered sunspots and solar flares, dark and light phenomena that danced across the solar surface, hinting at the immense energy and complex processes at play. These initial observations laid the groundwork for our understanding of the sun and its impact on Earth. As the centuries progressed, so too did our technological prowess. The advent of the telescope brought the cosmos closer, but it was the evolution of solar observatories and space-based telescopes that marked a new era in solar astronomy. The mid-20th century saw the launch of the first satellites dedicated to observing the sun, providing a vantage point unobstructed by Earth's atmosphere. This was a quantum leap forward, offering us a continuous view of our star in multiple wavelengths, day and night. In the 21st century, our quest to understand the sun has led to the development of cutting-edge observatories equipped with instruments so precise they can measure the magnetic fields and plasma flows of the sun's surface and beyond. The Daniel K. Inouye Solar Telescope, for instance, stands as a titan among these modern marvels. With its unparalleled resolution, it allows us to observe the sun's magnetic field in exquisite detail, offering insights into phenomena like solar flares and coronal mass ejections with unprecedented clarity. Moreover, the Parker Solar Probe, launched in 2018, is on a daring mission to touch the sun. Well, almost. It aims to travel closer to the sun's surface than any spacecraft before it, braving extreme temperatures and radiation to gather data that could solve long-standing mysteries about the sun's corona and its influence on space weather. The threat of coronal mass ejections. In the cosmic dance of celestial forces, the sun plays a pivotal role, not just as the source of light and life, but also as a harbinger of potentially catastrophic phenomena. Among these are the coronal mass ejections, or CMAs, vast expulsions of plasma and magnetic fields from the sun's corona, the outermost part of the sun's atmosphere. While solar flares are intense bursts of radiation that can light up the Earth's sky with dazzling auroras, CMAs are a different beast altogether. They release huge bubbles of gas and magnetic fields into space. When these bubbles strike the Earth, they can cause geomagnetic storms capable of wreaking havoc on our planet's magnetic field. The difference between solar flares and CMAs is not just in their nature, but also in their impact. While solar flares affect Earth's atmosphere in the form of electromagnetic radiation, CMAs carry with them the physical matter from the sun, which can interact with Earth's magnetic field in more profound ways. This interaction can lead to severe disturbances in the geomagnetic environment, known as geomagnetic storms. The potential for CMAs to cause extensive damage to Earth's infrastructure is not a matter of speculation, but a reality we have glimpsed in historical events. The charged particles from these ejections can induce electric currents in power lines, leading to widespread power outages and damaging transformers and other vital components of the electrical grid. In an age where our society is ever more dependent on technology and electrical power, the threat posed by CMEs extends beyond mere inconvenience. A powerful enough CME could disrupt communication networks, GPS systems, and even lead to the failure of critical infrastructure such as water supplies and transportation systems. The Sun's magnetic field and its effects. The Sun's magnetic field is a complex and dynamic feature, far from being a uniform or stable presence. It comes to life due to the roiling, convective movements of plasma that churn beneath the Sun's surface, creating a magnetic field that is both powerful and changeable. This field is at the heart of the Sun's periodic bursts of energy, which we see as solar flares and coronal mass ejections, CMAs. However, the mechanism that triggers these powerful events is a subject of fascination and study. At the core of these explosive phenomena is the process known as magnetic reconnection. To visualize it, think of the Sun's magnetic field lines as strands of energy that are constantly moving, intertwining, and evolving. Occasionally, these lines can break and then reconnect in different arrangements. When they do, they release a tremendous amount of energy in a short time. Magnetic reconnection acts as the trigger for solar flares and is the force that launches CMAs into the vastness of space. The impact of these solar events goes well beyond the confines of the Sun. Solar flares emit intense radiation that can disturb the Earth's atmosphere, leading to disruptions in satellite operations and communications networks. The threats from CMAs are even more significant. These gigantic clouds of plasma, when thrown into space, can have dramatic effects if the Earth is in their trajectory. The consequences range from the creation of spectacular auroras to intense geomagnetic storms. Such storms have the potential to damage our electrical grids and technological systems, highlighting the profound influence of solar activity on our daily lives and the technology we depend on. The latest solar flare event. In an unexpected twist in the saga of celestial phenomena, the Sun recently demonstrated its formidable power by releasing its strongest solar flare in almost 2 decades, an event that has become a landmark in the study of solar activities. This massive explosion of electromagnetic energy, categorized as an X 2.8 class flare, has not only riveted the global astronomical community, but also highlighted the Sun's capricious nature. Originating from a dynamic sunspot labeled AR 3514, the flare blasted through the cosmos, serving as a vivid testament to the immense influence of solar phenomena on our technological realm. The effects of the solar flare were swiftly felt on Earth, manifesting as a moderate radio blackout across South America. This incident served as a stark indication of our fragile standing in the face of the Sun's unpredictable temperament. Moreover, this solar event adorned the skies with magnificent auroras, which stretched well beyond their usual geographic bounds, providing a stunning spectacle of natural beauty. Despite the awe-inspiring visuals, these occurrences bear a cautionary note regarding the potential destructions that such solar activities can pose to our deeply interconnected global systems, reminding us of the delicate balance between technological advancement and cosmic forces. Preparing for future solar storms. In anticipation of future solar storms, scientists and researchers have embraced a comprehensive strategy that includes early detection, a deeper understanding of solar phenomena, and the development of effective mitigation plans. This strategic approach is greatly supported by the deployment of cutting-edge solar observatories, which have vastly enhanced our capability to predict and brace for solar events. Among these advancements, the National Science Foundation's Daniel K. Inouye Solar Telescope stands out as a significant milestone in our observational efforts. Equipped with the latest scientific instruments, including 4 spectropolarimeters designed to measure the Sun's magnetic properties, the DKIST offers invaluable insights into the intricate magnetic field of the Sun, spanning its corona, chromosphere, and photosphere. These state-of-the-art observatories play a crucial role beyond mere observation. They act as an advanced early warning system for our planet. By analyzing the magnetic field of coronal mass ejections, CMAs at the moment they occur, scientists can determine the direction and potential impact of these charged particles. This is vital for assessing whether the ejected material will pose a threat to Earth. Armed with this knowledge, we can predict the arrival of solar storms well in advance, providing a precious window for taking protective measures. These measures are aimed at safeguarding critical infrastructure, including our electrical grids, communication networks, and satellites from the potentially devastating effects of solar storms. Moreover, the focus on developing and refining predictive models of the sun's behavior has become increasingly important. These models, powered by the wealth of data collected by solar observatories, are crucial for improving our understanding of solar dynamics. They enable scientists to predict solar activities and storms with a higher degree of accuracy, making it possible to anticipate and mitigate the impact of these celestial events on Earth. This multifaceted approach exemplifies the proactive steps being taken to protect our planet from the powerful forces of our closest star, ensuring a higher level of preparedness for future solar phenomena. In confronting the unpredictable fury of solar storms, humanity's resolve shines as brightly as the phenomena we seek to understand. Leveraging advanced observatories and scientific ingenuity, we stand prepared, not just to withstand the sun's might, but to thrive in its presence. This commitment to foresight and resilience illuminates our path forward, ensuring that as we gaze up at the cosmos, we do so not with fear, but with the confidence of those ready to meet the future. We hope you found these facts intriguing. If you've heard them before or have any thoughts to share, please let us know in the comments below. Don't forget to give us a thumbs up and subscribe to A World to Discover to join us on our journey of discovery. While you're still here, feel free to click on other videos you will see on the screen right now.
The little spacecraft that could, Voyager 2, is heading for its closest encounter yet with the planet Neptune. It's now billions of miles from...
While Jupiter boasts its mesmerizing storms, Mars captivates with its potential for life, and Saturn dazzles with its stunning rings. Courtesy of the Cassini spacecraft's 13-year grand tour, Neptune seems to quietly orbit in the distant chill of space. It's the 8th planet from our Sun, remote and enigmatic, often overlooked in the bustling solar system family. So why does Neptune receive less attention compared to its planetary siblings? Let's dive deep into the blue to uncover the mysteries and majesty of this distant ice giant. Join us as we explore what makes Neptune unique and why it deserves a closer look. Named after the Roman god of the sea, Neptune is often referred to as an ice giant, due to its composition, which consists primarily of hydrogen, helium, and traces of methane. With a diameter about 4 times that of Earth, Neptune boasts a striking blue hue attributed to the presence of methane in its atmosphere, which absorbs red light and reflects blue. Discovered in 1846, Neptune's exploration has been limited compared to its closer planetary counterparts. However, the historic flyby of NASA's Voyager 2 spacecraft in 1989 provided invaluable insights into this distant planet, unveiling its dynamic weather patterns, unique moons, and fascinating rings. Among its moons, Triton stands out for its retrograde orbit, moving opposite to Neptune's rotation, suggesting a complex history of capture and gravitational interactions. Neptune's atmosphere is characterized by powerful storms, including the Great Dark Spot, reminiscent of Jupiter's Great Red Spot, showcasing the planet's turbulent and dynamic nature. Despite its remote location and challenges associated with exploration, Neptune remains a target of scientific curiosity, offering valuable opportunities to expand our understanding of planetary systems and the evolution of our solar system. While Mercury often steals the spotlight in astrology due to its perceived retrograde motions, which enthusiasts often blame for disruptions and challenges, the truth is far less mystical. It's merely an optical illusion resulting from the relative positions of Earth and Mercury in their orbits. However, despite Mercury's frequent appearances in astrological discussions, Neptune remains largely overlooked. Its astrological influence, while less discussed, is equally intriguing, governing realms of dreams, intuition, and mysteries. This discrepancy between the attention given to Mercury and the relative neglect of Neptune in astrology reflects the elusive and distant nature of the latter within the solar system. It underscores the vast difference between the roles planets play in astrology and their exploration in the realms of physical science. Focus on ice giants. Neptune and Uranus, often overshadowed by their larger gas giant cousins, hold a special place in the pantheon of our solar system as ice giants. This classification stems not from their being literal ice, but from their intriguing construction, largely from substances like water, ammonia, and methane, which in the cold depths of space form icy compounds. Both planets share a similar size, being significantly larger than Earth yet smaller than Jupiter and Saturn, which places them in a unique category of their own. Their atmospheres are thick with hydrogen and helium, but it's the methane that really sets them apart, absorbing red light and giving these distant worlds their characteristic blue hues. What's particularly fascinating about Neptune and Uranus is their internal structure, which, under extreme pressures, might form diamonds from compressed carbon atoms, a phenomenon that remains a tantalizing possibility not observable on the gas giants. This unusual atmospheric and internal chemistry makes Neptune and Uranus key subjects in planetary science, offering insights into not only planetary formation and evolution, but also into conditions that are utterly alien compared to those found on terrestrial planets. The mystery of Neptune's color. In a fascinating twist of scientific inquiry, a study initially focused on the broader atmospheric characteristics of Neptune ended up shedding light on one of the planet's most captivating mysteries, its striking blue color. Led by Patrick Irwin, a planetary physicist at Oxford University, the team set out to explore the atmospheres of both Neptune and Uranus. Their research was not originally intended to delve into why Neptune exhibits such a vivid azure hue. However, the findings inadvertently provided valuable insights. The team discovered that Neptune's color is primarily due to the absorption of red light by methane in its atmosphere, which leaves behind the richer blues and greens that we see. Further analysis revealed an interesting distinction between Neptune and its celestial twin, Uranus. It turns out that Neptune has a thinner layer of methane haze compared to Uranus. This thinner haze allows for a deeper, more intense blue to emerge, setting Neptune apart in the visual spectrum of the solar system. This discovery highlights how scientific journeys can sometimes yield unexpected yet enlightening results, deepening our understanding of the planets beyond our Earth. History of exploring Neptune. Neptune's exploration story, though not as extensively documented as Mars or Jupiter's, is undeniably captivating. A pivotal moment in our comprehension of Neptune unfolded with NASA's Voyager 2 spacecraft embarking on a historic flyby in 1989. This mission stands as the sole instance where we've had the opportunity to closely observe Neptune. As Voyager 2 soared past, it bestowed upon us breathtaking images that revolutionized our perception of this distant world. It unveiled a vividly blue planet, adorned with subtle rings and intriguing moons. Among these, Triton stands out, its orbit around Neptune defying convention by moving opposite to the planet's rotation, hinting at a potentially unique origin story. Voyager 2's flyby yielded invaluable insights into Neptune's atmosphere, unveiling its dynamic weather patterns, including the remarkable discovery of the Great Dark Spot, an Earth-sized storm showcasing Neptune's tumultuous nature. This mission profoundly enriched our comprehension of the outer planets and endures as a pivotal moment in planetary science. Through Voyager 2's journey, we ventured farther into the depths of our solar system, unraveling the mysteries of Neptune and expanding our understanding of the vast celestial landscape beyond. Neptune's storms and atmospheric phenomena. Neptune's atmosphere is alive with dramatic weather phenomena, most notably its storms, which can be as captivating as they are mysterious. The most famous of these is the Great Dark Spot, discovered by NASA's Voyager 2 during its 1989 flyby. This massive storm, roughly the size of Earth, showcased the fastest winds ever recorded in our solar system, reaching speeds of up to 200 kilometers per hour. However, unlike Jupiter's Great Red Spot, which has raged for centuries, Neptune's storms show much shorter lifespans. The Great Dark Spot had completely vanished by the time the Hubble Space Telescope observed Neptune in 1994, illustrating just how quickly these colossal weather systems can change. These rapid transformations hint at a highly dynamic atmosphere where storms develop and dissipate much faster than on Jupiter. The fleeting nature of these storms poses a significant challenge for scientists trying to study them. By the time a telescope like Hubble makes a return observation, the atmospheric landscape may have completely altered. This transient behavior makes Neptune's atmosphere one of the most volatile and least understood among the solar system's giants, inviting more in-depth exploration to unravel its meteorological mysteries, role of Triton, and other moons. As we delve deeper into Neptune's celestial family, we cannot overlook Triton, Neptune's largest moon. This intriguing moon captures the imagination with its peculiar retrograde orbit, meaning it moves in the opposite direction to Neptune's rotation. This unusual path suggests a dramatic origin story for Triton, likely captured by Neptune's gravity rather than forming alongside it. Such a capture is not just a spectacle of celestial dynamics, but sheds light on the migration histories of other objects in our solar system. Triton isn't just notable for its orbit. It's slightly larger than our own moon and showcases a surface rich with geological features, pointing to a potentially vibrant past. This includes the likelihood of a subsurface ocean, making Triton a key player in Neptune's system and a target of high scientific interest. Surrounding Neptune, several other moons orbit, most of them smaller and irregularly shaped compared to Triton. These moons, along with the planet's delicate ring system, form a complex gravitational dance that influences the system's stability and evolution. Understanding these interactions helps astronomers piece together the dynamic processes governing the outer solar system, providing clues about the formation and evolution of planetary systems as a whole. Current and future observations. The James Webb Space Telescope, JWST, our most advanced space observatory, has recently turned its powerful gaze towards Neptune, offering us some of the clearest and most detailed images of this distant planet in over 3 decades. With JWST's sophisticated instruments, we're peering into the icy depths of Neptune's atmosphere and gaining unprecedented views of its intricate ring system and numerous moons. The telescope's ability to capture high-resolution images in infrared light has illuminated features that were previously too faint to discern. This includes several of Neptune's lesser-known moons and the fine particles that compose its rings, revealing new details about their composition and dynamics. These observations are crucial as they not only enhance our understanding of Neptune's physical properties, but also help astronomers piece together the planet's evolutionary history and its current meteorological phenomena. The data gathered by JWST is expected to keep scientists busy for years, unlocking secrets of the furthest reaches of our solar system. This rich influx of data from JWST marks a significant milestone in our quest to understand Neptune's complex climate system, its unique atmospheric chemistry, and its dynamic environment. Challenges in exploring Neptune. Exploring Neptune presents unique challenges, primarily due to its immense distance from the Sun, approximately 4.5 billion kilometers away. This vast expanse not only increases travel time and costs, but also poses significant technical hurdles for communication and power supply. Spacecraft venturing to Neptune must rely on radioisotope thermoelectric generators for power, as solar energy is too weak at such distances. These generators convert the heat from radioactive decay into electricity, providing a reliable source of power for the spacecraft's instruments and systems. Moreover, Neptune's remote location means that any mission there faces prolonged communication delays, complicating real-time command or data retrieval. The round-trip communication time between Earth and Neptune can range from hours to days, depending on the positions of the planets in their respective orbits. This isolation requires spacecraft systems to operate autonomously for extended periods, making them highly reliant on pre-programmed commands and onboard decision-making algorithms. Despite these difficulties, Neptune's exploration is crucial for understanding the outer solar system and uncovering the mysteries of ice giants. By studying Neptune's atmosphere, magnetic field, and moons, scientists can gain insights into planetary formation and evolution beyond the realm of terrestrial planets. However, these logistical complexities have led to Neptune being visited less frequently than its closer and perhaps more immediately intriguing planetary neighbors like Mars and Jupiter. Nonetheless, the scientific community continues to advocate for future missions to Neptune, recognizing the invaluable knowledge they could yield about our solar system's distant frontier, future missions, and scientific goals. In the realm of planetary exploration, the scientific community has set its sights on some ambitious missions for the future, with Neptune featuring prominently in their plans. Currently, there's a lively debate about the next big target for a dedicated orbital mission in our outer solar system. While Neptune remains a candidate for exploration, the focus has somewhat shifted towards Uranus. Scientists recommend prioritizing a mission to Uranus within the next decade, citing its accessibility and the potential to yield significant scientific data swiftly. Despite this prioritization, the fascination with Neptune continues to grow, compelling the scientific community to consider a detailed exploration of this distant planet. A proposed mission plan suggests launching a spacecraft to Neptune around 2033, with an expected arrival in 2049. This timeline could be extended if Uranus is indeed chosen first, possibly pushing Neptune's close examination to the mid-2050s. The goals of these future missions are robust and revolve around a deeper understanding of the ice giants. Researchers aim to study Neptune's dynamic atmosphere, its intriguing storm systems, and its magnetic environment. Moreover, there's a strong interest in Neptune's moons, particularly Triton, with its retrograde orbit and geologically active surface, which could provide crucial insights into the solar system's history and evolution. These missions are expected to deliver groundbreaking data, helping to unravel some of the enduring mysteries of our solar system's most distant planets. Neptune occupies a unique position as the most distant major planet in our solar system, often overlooked in the race to explore closer and more accessible celestial bodies. Its status as an underappreciated giant belies the intriguing mysteries and scientific potential it holds. As the final frontier in planetary exploration, Neptune offers a gateway to understanding not only the dynamics of ice giants, but also the broader mechanisms at play in the outer reaches of our solar system. Future missions to Neptune could unravel these enigmas, enhancing our knowledge of planetary formation, evolution, and the peculiarities that govern such distant worlds. As we consider sending probes to its orbit, the lessons learned from Neptune will likely illuminate countless unknowns about our cosmic neighborhood, underlining the importance of reaching out to this distant blue planet. We hope you found these facts intriguing. If you've heard them before or have any thoughts to share, please let us know in the comments below. Don't forget to give us a thumbs up and subscribe to A World to Discover to join us on our journey of discovery. While you're still here, feel free to click on other videos you will see on your screen right now. For over a century since Einstein first predicted their existence in 1916, the scientific community and enthusiasts alike have been captivated by the allure of capturing an actual photograph of a black hole. These cosmic giants, powerful beyond comprehension yet invisible to the naked eye, stir both awe and mystery in our quest for understanding the universe. As we explore these massive beasts of the cosmos, we delve into how something so immensely powerful can remain virtually unseen, hidden within the very fabric of space-time itself. Join us as we uncover the secrets of these mysterious phenomena.
Now we've got it in the bag. We've actually photographed the silhouette, the shadow of a black hole. But that's just the
historical context and theoretical foundations. Albert Einstein's groundbreaking theory of general relativity in 1916 revolutionized our understanding of gravity and the cosmos, predicting phenomena that even he could barely imagine, including black holes. These theoretical voids in the fabric of space-time, where gravity's pull is so strong that nothing, not even light, can escape, remained a mathematical curiosity for decades. It wasn't until the 1960s that black holes shifted from theoretical constructs to observable realities. Astronomers studying the Cygnus constellation observed a blue star emitting unusual X-rays and behaving erratically around an invisible partner. This led to the discovery of Cygnus X1, a compelling candidate for a black hole, providing the first physical evidence that these cosmic behemoths were not just theoretical fantasies, but real astronomical entities in our universe. First discovery and characteristics of black holes. The story of black holes took a dramatic turn with the discovery of Cygnus X1. In the 1960s, astronomers studying the Cygnus constellation were intrigued by an unusually bright blue star emitting X-rays at an extraordinary rate. This was no ordinary celestial body. It was a stellar phenomenon behaving in ways that defied initial understanding. Further investigation revealed that these X-rays were not just emanating on their own, but were being intensely pulled into a nearby invisible object, which we now know as a black hole. This discovery was pivotal because it provided the first concrete evidence of black holes' existence, confirming Albert Einstein's theoretical predictions. Cygnus X1 exhibited properties that were both fascinating and terrifying. It shone with a luminosity about 14 times that of our Sun, yet its gravitational pull was so strong that not even light could escape it, rendering the black hole invisible and justifying its name. This immense gravitational force is crucial for understanding why black holes are such a significant find in the cosmos. They are not merely vacuums in space, but regions where gravity reshapes the very fabric of reality. This blend of visible indicators and invisible forces made Cygnus X1 a landmark in astronomical studies and sparked a renewed interest in probing deeper into the nature of black holes, research evolution, and modern understanding. Over the decades, our understanding of black holes has transformed dramatically. From theoretical predictions to tangible evidence, the journey culminated in a groundbreaking moment in 2021 when scientists captured the first clear photograph of a black hole located in the M87 galaxy. This image wasn't just a snapshot. It was a major leap in cosmic photography achieved by linking telescopes worldwide to create a planet-sized interferometer, which provided the necessary resolution to see the unseeable. The photograph itself revealed much more than expected. It gave us a direct look at the event horizon, or the point of no return, where gravitational pull becomes so strong that not even light can escape. This allowed astronomers to confirm several theoretical predictions about black holes' behavior and structure. By observing the glowing gas orbiting at the edge of the event horizon, researchers could measure the black hole's massive influence on its surroundings, offering new insights into how matter behaves in such extreme environments. This not only validated some of Einstein's predictions about general relativity, but also opened new avenues for understanding the fundamental laws of physics in the most extreme conditions known in the universe. The layers of a black hole. Diving deeper into the anatomy of a black hole reveals a complex structure composed of distinct layers, each playing a critical role in its function and behavior. The outermost layer, known as the event horizon, is famously termed the point of no return. It marks the boundary beyond which nothing, not even light, can escape the gravitational pull of the black hole. This layer defines the visible outline of the black hole and acts as a gateway to its mysterious inner workings. Moving closer to the core, we encounter the photon sphere. This is a not-so-well-known layer where gravity is so strong that photons, particles of light, are forced into orbital paths around the black hole. Here, light bends around the black hole in a mesmerizing cosmic dance, creating loops of brilliant light that can sometimes be observed with sophisticated telescopes. The photon sphere is crucial for astronomers trying to see and study black holes indirectly by observing how light behaves in this extreme environment. At the very heart of a black hole lies the singularity, a point where the laws of physics as we know them break down. In this region, matter is crushed to infinite density, and the gravitational pull is infinitely strong. The singularity represents one of the greatest mysteries in modern physics. It's where our understanding of gravity, space, and time is challenged, and where current theories reach their limits. Each layer of a black hole, from the event horizon to the singularity, not only contributes to its intriguing nature, but also offers a unique playground for testing the theories of physics in extreme conditions. The nature and dangers of black holes. Black holes are not just fascinating scientific phenomena, they are also incredibly dangerous regions of space. At the heart of their danger is their intense gravitational pull, a force so strong that nothing, not even light, can escape once it crosses the event horizon. This boundary marks the point of no return. For any object unfortunate enough to get too close, the outcome is both dramatic and fatal. This leads us to the gruesome concept of spaghettification. Imagine you're falling feet first into a black hole. The gravitational pull on your feet would be significantly stronger than on your head, stretching you longer and thinner like spaghetti. This stretching happens because different parts of your body experience different intensities of gravity. Eventually, this effect becomes so extreme that it tears apart anything caught in its grasp, atom by atom. The perils of black holes extend beyond the immediate destruction of material objects. Their presence can disrupt nearby stellar environments, drawing in and accumulating gas, dust, and other celestial debris in a swirling accretion disk. This accumulation can lead to energetic emissions and powerful jets that reshape their cosmic neighborhood. Thus, the very nature of black holes as regions of extreme gravity makes them not only fascinating to study, but also incredibly hazardous to anything within their reach. Recent photographic breakthroughs. In a groundbreaking achievement, scientists have recently managed to capture the first clear images of a black hole, specifically the M87 black hole. This monumental event in astrophysics not only confirms the existence of black holes, but also allows us to peek into the dynamic processes that govern these enigmatic features of our universe. By stitching together multiple photographs taken over several nights, researchers have developed a more comprehensive view of the black hole structure. These images reveal fascinating details about the black hole's behavior, particularly how matter and light behave around this extreme gravitational force. This insight is crucial as it helps scientists understand the accretion processes and the emission of powerful jets that extend thousands of light years into space. The ability to visually observe these phenomena provides unprecedented information, transforming our theoretical knowledge into tangible, observable facts. This data is vital for testing the limits of our current physical theories and potentially guiding us towards new discoveries in black hole dynamics and the fundamental laws of physics. Black hole theories and spinning black holes. In 1963, Roy Kerr revolutionized our understanding of black holes with his groundbreaking model that described not just any black hole, but those that spin. This concept introduced us to the idea of rotating black holes, which differs significantly from the non-spinning versions predicted by earlier theories. Kerr's model proposes that the space around these spinning black holes twists along with them, leading to the formation of something known as the ergosphere. This region, lying just outside the event horizon, is where the effects of the black hole's spin are most pronounced. Matter and radiation can enter the ergosphere and receive energy from the black hole's rotation, potentially being flung out at great speeds. The implications of Kerr's model stretch even further with the theoretical possibility of the Einstein-Rosen bridge, commonly referred to as a wormhole. This hypothetical feature suggests a tunnel-like pathway through space-time, facilitated by the unique structure of spinning black holes. Theoretically, these bridges could connect two distant points in the universe, or potentially link to parallel universes. While the existence of such wormholes remains speculative, the discussion it sparks among physicists and the general public alike continues to fuel both scientific inquiry and popular fascination with the cosmos. Wormholes and interstellar possibilities. Wormholes capture the imagination as potential shortcuts through the vastness of space-time, offering hypothetical routes that could connect distant or even parallel universes. Derived from Einstein's equations, these intriguing structures are theorized to form tunnels between disparate points in the cosmos, potentially allowing for instantaneous travel across astronomical distances. However, the science behind wormholes is fraught with challenges. Current understanding suggests that while they may theoretically exist, wormholes would likely be highly unstable, collapsing too quickly for anything to pass through without extraordinary amounts of negative energy, something not currently understood to exist in the necessary quantities. This instability has led many scientists to approach the concept of practical wormhole travel with skepticism, maintaining a cautious perspective on the feasibility of using these cosmic phenomena as pathways for interstellar travel. Despite these hurdles, the study of wormholes continues to be a vibrant area of theoretical physics, pushing the boundaries of our understanding of the universe. Superstring theory and its implications. Superstring theory offers a groundbreaking perspective on the unification of the universe's most fundamental forces. This theory suggests that what we perceive as particles are actually tiny vibrating strings, each resonating at specific frequencies. Unlike traditional particle physics, superstring theory requires a universe with 10 dimensions, far beyond the 4 dimensions of space and time that we experience daily. These additional dimensions aren't just theoretical quirks. They are essential for the mathematics of the theory to work properly, providing a framework that could potentially explain every force and particle in the universe. This bold idea not only bridges the gap between Einstein's theory of general relativity, which governs the cosmos at the largest scales, and quantum mechanics, which reigns over the smallest, but it also offers explanations for phenomena that otherwise defy classical explanations. For instance, superstring theory could elucidate the nature of black holes, which challenge our understanding of both gravity and quantum mechanics. By viewing these cosmic puzzles through the lens of superstring theory, physicists hope to unlock answers to some of the most profound questions about the structure and origins of the universe, experimental challenges, and theoretical developments. Studying black holes presents unique challenges to scientists, primarily because these cosmic phenomena do not emit light, making them invisible to traditional observation methods. Researchers must instead rely on indirect methods, such as observing the gravitational effects black holes have on nearby stars and gas clouds. This indirect approach adds layers of complexity and uncertainty to their studies. Further complicating the study of black holes is the theoretical framework of superstring theory. This advanced theory suggests that all fundamental particles are not point-like dots, but rather tiny vibrating strings. Superstring theory is a leading candidate in the quest to unify Einstein's theory of general relativity with quantum mechanics. However, it posits the existence of 10 dimensions, 6 beyond the 3 spatial dimensions and 1 time dimension we experience daily. These extra dimensions are theorized to be compact and rolled up so tightly that they are beyond our current capability to observe directly, posing a significant hurdle for empirical validation. The unstable properties of theoretical constructs like wormholes add another layer of complexity. Wormholes, predicted by the equations of general relativity under specific conditions, are passages through spacetime that could, in theory, connect distant parts of the universe or different universes altogether. However, the inherent instability of these wormholes and the extreme conditions likely found at their entrances, such as intense radiation and crushing gravitational forces, make them difficult to study or even confirm their existence scientifically. These challenges mean that much of what we understand about black holes and related phenomena remains speculative, relying on advancing theoretical physics and improving observational technologies to bring these cosmic mysteries into clearer view. The Big Bang and beyond in string theory. String theory offers a fascinating twist on the Big Bang theory, suggesting that what we perceive as the universe's beginning might actually be far more complex. According to this theory, our universe could potentially be the product of 2 separate universes colliding, or a universe birthing another, akin to a cosmic child emerging from its parent. This interconnection between universes is conceptualized through what's known as wormholes, which are theorized as cosmic tunnels linking disparate parts of the universe or even different universes altogether. The implications of this are staggering. If wormholes are real and stable enough to connect different realms of space-time, our current understanding of our place in the cosmos could be fundamentally altered. It raises the possibility that what we consider black holes might actually be gateways or bridges to other dimensions or distant parts of our universe. This leads to an even more bewildering possibility. Could our entire observable universe be inside a black hole located in a much larger universe? Such a scenario would redefine concepts of beginning and end and what it means to exist in this universe. As we continue to explore these profound questions, the mysteries of the cosmos keep our curiosity piqued, pushing the boundaries of our understanding of the very fabric of reality. We hope you found these facts intriguing. If you've heard them before or have any thoughts to share, please let us know in the comments below. Don't forget to give us a thumbs up and subscribe to A World to Discover to join us on our journey of discovery. While you're still here, feel free to click on other videos you will see on your screen right now.
If you go to the early universe, right after the Big Bang, it was expanding way faster than the speed of light.
Imagine unraveling the mysteries of the universe, where every discovery shifts our understanding of cosmic origins, structure, and fate. The James Webb Space Telescope has thrown a curveball at physicists, challenging what we thought we knew with a single image that rewrites the rules. As we dive into the realms of the Hubble constant controversy and the enigmatic SA tension, we find ourselves at the edge of a scientific revolution. What new physics might emerge from this cosmic puzzle? Could we be on the brink of redefining our place in the universe? What do you think lies beyond our current understanding? How will these discoveries shape our future in the cosmos?
The sun will have a fate such as this, where at the end its outer layers of gas will escape into space.
Cosmology's crisis. In the heart of modern astrophysics lies a puzzle that has perplexed scientists for years, known as the crisis in cosmology. This profound enigma stems from a significant discrepancy between two primary methods of estimating the universe's age and expansion rate. On one hand, local measurements, which scrutinize astronomical objects within our universe, such as Cepheid variable stars and Type Ia supernova, suggest a certain pace of expansion. On the other, early universe measurements, derived from observations of the cosmic microwave background radiation, the universe's oldest light, paint a different picture, hinting at a slower rate of expansion. This persistent disagreement has not only fueled a fiery debate among scientists, but has also launched a series of research efforts aiming to unravel the underlying cause. Whether this discrepancy points to new physics at play or systematic errors in our measurements, it underscores the dynamic and ever-evolving nature of cosmological science. As we stand at the crossroads of this cosmic dilemma, the journey to solve the crisis in cosmology continues to be a testament to our relentless pursuit of understanding the universe's deepest secrets. Hubble constant controversy. At the heart of modern cosmology lies the Hubble constant controversy, a profound puzzle that has scientists across the globe scratching their heads. This controversy stems from the conflict between two primary methods of measuring the universe's expansion rate. On one side, we have local measurements, which rely on observing standard candles like Cepheid variables and Type Ia supernova. These celestial markers, whose intrinsic brightness we understand well, allow astronomers to calculate distances and thus estimate the rate at which the universe is expanding. On the other side are early universe measurements derived from the cosmic microwave background radiation, the afterglow of the Big Bang, offering a snapshot of the universe at a much younger age. Surprisingly, these two approaches yield significantly different values for the Hubble constant, suggesting we might either be on the cusp of uncovering new physics that could revolutionize our understanding of the cosmos, or facing systematic errors in our measurements that need addressing. This discrepancy not only highlights the complexities of cosmic measurement, but also serves as a tantalizing indication that the universe may still have secrets to reveal, potentially reshaping our cosmic models and theories. JWST's early observations. The James Webb Space Telescope, with its unprecedented resolution and sensitivity, promised to usher in a new era in our understanding of the cosmos, particularly by refining measurements of the Hubble constant, which charts the universe's expansion rate. Yet, early observations from this marvel of modern astronomy have done more than just refine. They complicated the cosmic picture even further. As we peered back in time to the universe's earliest epochs, the data gathered didn't snugly fit into our existing models. This unexpected twist has not only intensified the debate around the universe's expansion rate, but also hinted at the potential for undiscovered aspects of physics, suggesting that the universe might be more intricate and mysterious than our current scientific framework allows. This development underscores a pivotal moment in cosmology, where each observation is a step toward unraveling the universe's most profound mysteries. proving that the cosmos still holds secrets beyond our current grasp. Implications of the crisis. The unfolding crisis in cosmology, marked by the striking discrepancies between different measurements of the universe's expansion rate and its clumpy structure, beckons a profound reevaluation of our cosmic understanding. As we stand at the crossroads of discovery, the potential implications of this crisis stretch far beyond mere academic curiosity, hinting at the necessity for a paradigm shift in the standard model of cosmology. Such a shift could entail the introduction of new, previously unknown particles or forces that subtly govern the fabric of the cosmos, or it might require a radical rethinking of dark energy, the mysterious force accelerating the universe's expansion. These theoretical upheavals are not just reshaping our cosmic models, but also paving the way for groundbreaking advancements in physics, promising to unlock deeper secrets of the universe. This moment in scientific history could very well mark the dawn of a new era in cosmology, where our understanding of the universe undergoes its most significant transformation yet. Historical context. Throughout history, the field of cosmology has witnessed dramatic shifts, each new discovery pushing the boundaries of our cosmic comprehension. It began over a century ago with the Big Bang Theory, an idea that posited our universe as expanding from a singular, incredibly dense state approximately 13.8 billion years ago, a model that fundamentally altered our grasp of cosmic evolution. This expansion, quantified by the Hubble constant, became a cornerstone of modern astrophysics. Yet the journey of cosmological discovery didn't stop there. In the late 1990s, observations of distant supernovae unveiled that the universe's expansion was accelerating, not decelerating as previously assumed. This led to the groundbreaking introduction of dark energy, a mysterious force driving this acceleration, which challenged and extended our existing models. Each of these milestones, from the discovery of the cosmic microwave background radiation in 1965, which provided compelling evidence for the Big Bang Theory, to the later understanding of dark energy, has necessitated the constant evolution of our cosmic theories. These shifts not only exemplify the dynamic and self-correcting nature of scientific inquiry, but also underscore the importance of remaining open to new data and the mysteries it may unveil, pushing us toward a deeper understanding of the universe's intricate dance. The SA tension. The SA tension, a phenomenon less widely recognized than the Hubble tension, yet equally perplexing, underscores a profound discrepancy in our observations of the universe's clumpiness, challenging the coherence of cosmic evolution as we understand it. This tension arises from conflicting measurements of matter's distribution and density across the cosmos, a fundamental aspect that significantly influences our comprehension of cosmic structure and history. While low redshift observations, particularly those involving weak gravitational lensing, paint a picture of a universe where matter clumps together in a certain pattern, the cosmic microwave background, CMB, the afterglow of the Big Bang, suggests a smoother distribution of matter than what we observe in our nearby universe. This discrepancy not only highlights a potential gap in our understanding of the universe's evolution from its nascent, smooth state to its current clumpy configuration, but also signals the tantalizing possibility that new physics might be required to reconcile these conflicting views. As we stand on the brink of potentially groundbreaking discoveries, the resolution of the SA tension could redefine our understanding of the cosmos, marking a pivotal moment in the field of cosmology. The Flamingo Project. In the heart of the cosmological enigma lies the Flamingo Project, a colossal computational endeavor designed to pierce through the veil of the SA tension. This tension, a stark discrepancy in the universe's matter distribution and density, has left scientists scratching their heads. Leveraging one of the globe's most formidable supercomputers at Durham University, Flamingo represents an ambitious leap into the unknown, consuming over 50 million hours of compute time across 30,000 processors. Its aim: to simulate the cosmos not just in fragments, but in its overwhelming entirety, from the swirling galaxies to the enigmatic supermassive black holes at their centers. This was no ordinary simulation. It was a universe in silico, embodying both the dark and ordinary matter that weaves the fabric of everything. Yet, despite its groundbreaking approach and the staggering detail it provided, Flamingo encountered the humbling vastness of cosmic mysteries head-on. The SA tension remained unresolved, a testament to the profound complexities of marrying theoretical physics with the raw, unyielded data from the cosmos. The Flamingo project, with all its computational might, underscored a critical junction in cosmology: the persistent challenge of aligning our most advanced models with the intricate tapestry of observational evidence. Ongoing challenges and opportunities. In the vast and ever-expanding field of cosmology, the ongoing challenges such as the Hubble and SEA tensions are not merely scientific quandaries, but catalysts for innovation and collaboration. These tensions, arising from discrepancies in the universe's expansion rate and its clumpiness, underscore the complex dance between observation, theory, and the unknown forces shaping our cosmos. They propel technological advancements, pushing us to develop more precise instruments that can peer deeper into the fabric of space and time, and foster international and interdisciplinary collaborations, uniting astronomers, physicists, and computational scientists in a collective quest to solve these cosmic puzzles. This dynamic nature of scientific inquiry, where every obstacle becomes a stepping stone, highlights the resilience and curiosity driving humanity's quest to understand the universe. As we stand at the crossroads of potentially revolutionary discoveries, these challenges remind us that the journey of exploration is as important as the destination, inviting us to reconsider our theories, expand our horizons, and perhaps redefine our place within the cosmos. This pursuit not only deepens our understanding of the universe, but also exemplifies the spirit of discovery that has propelled human knowledge forward through the ages. Future outlook. As we peer deeper into the cosmos with the unparalleled capabilities of the James Webb Space Telescope, we stand on the cusp of a new era in cosmology, one ripe with the potential for groundbreaking discoveries that could fundamentally alter our understanding of the universe. The persistent tensions and discrepancies observed, such as the Hubble constant controversy and the SEA tension, which challenge our models of cosmic expansion and matter distribution, are not merely obstacles. Instead, they represent invaluable opportunities to push the boundaries of current scientific paradigms. With JWST's advanced observational prowess, we are now equipped to probe the universe's earliest epochs, examine the first galaxies, and refine our measurements of cosmic expansion and matter distribution in unprecedented detail. This cutting-edge telescope is poised to address the SEA tension head-on, requiring meticulous observation and possibly the genesis of new theoretical insights. Whether it leads to a better understanding of dark energy, accounts for the behavior of dark matter, or uncovers entirely new physics, the implications are profound. The crises in cosmology, such as the Hubble and SEA tensions, are not stumbling blocks but stepping stones that drive the field forward, leading to more precise instruments, deeper theoretical insights, and ultimately a more comprehensive understanding of the cosmos. In this exciting journey of cosmic discovery, every challenge is a doorway to new knowledge, and the JWST is the key we have long been waiting for, promising to illuminate the darkest corners of our universe and perhaps reveal its most closely guarded secrets. We hope you found these facts intriguing. If you heard them before or have any thoughts to share, please let us know in the comments below. Don't forget to give us a thumbs up and subscribe to A World to Discover to join us on our journey of discovery. While you're still here, feel free to click on other videos you will see on the screen right now.